Ngalakin Khadijan Nyunga Boja.
Good afternoon. I think we'll make a start. I got a bit of a dilemma. My watch says it's just a couple of minutes after 2, but the university watch is still 5 minutes delayed. So the Vice Chancellor is working on it to fix it. So my name is Kadambot Siddique. I'm the director of the UWA Institute of Agriculture. Before we get started, I have a few housekeeping items to mention. So the Twitter will be happening today, so I invite you to tweet. I know the Vice Chancellor is a heavy tweeter. So the screen shows the Wi-Fi access username and password and the Institute Twitter handle. I'm very happy to report that today's event was sold out last week. However, due to COVID-19 restrictions, we are allowed only 60% of the capacity of the auditorium. Please remember to follow social distancing recommendations. Make use of the hand sanitizer at the entrance, which you have seen. In the unlikely event of any emergency, exits are located on both the front auditorium, left and right-hand side. The washrooms are located at the back, so you can exit via in the front door and then follow the corridor, round the left, past the outdoor foyer. You will not miss that. And now it's customary for the University of Western Australia to acknowledge that the university is situated on Noongar land, that the Noongar people remain the spiritual and cultural custodians of their land, and continue to practice their values, languages, beliefs, and knowledge. So I would like to now acknowledge Professor Amit Chakma, the Vice Chancellor, University of Western Australia, Professor David Sadler, the Deputy Vice Chancellor, Education, Honourable Colin D. Grassa, MLA, the Nationals, the Agricultural Region, Professor Tim Colmer, the Deputy Vice Chancellor, Research, University of Western Australia, Dr. Terry Enright, Chair of the UWA Institute of Agriculture Industry Advisory Board, and a number of Industry Advisory Board members are present here today. Invited speakers, distinguished guests, UWA colleagues, students, ladies and gentlemen. On behalf of the University of Western Australia, I would like to warmly welcome you to the UWA Institute of Agriculture's Industry Forum 2020. This is the annual event that is one of the highlights in our calendar, and 2020 marks the 14th consecutive Industry Forum. Over the years, we have explored many topics, from new technologies and innovation in agriculture to national and international shift in the industry, and still it is happening, to the big question of how to feed over the 9 billion people on the planet in 2050. I would like to especially thank CSBP, which is one of the largest fertilizer companies in Australia and in Western Australia, maybe in the Southern Hemisphere, for supporting this year's forum through CSBP and Farmers Golden Jubilee of Agriculture Science Fellowship, held as a bequest within the University of Western Australia. Each year, we look at the current and future trends in agriculture industry and bring together Western Australia's leading farmers, I think we have 2 this year, key industry leaders and researchers to provide their expert opinion on the topic. The UWA Institute of Agriculture Industry Advisory Board plays a major role in choosing the topic every year and in selecting the speakers. Vice Chancellor, this is the only industry advisory group have been functioning for the last 14 years without any disruption. So I really thank the Industry Advisory Board members and the chair. Many of the members doesn't want to retire. They say this is so exciting, so we want to stay on board. So the chairman has got a hard role to find new people to come on the board. As such, I would like to hand over to Dr. Terry Enright, who will be your master of ceremonies this afternoon. In addition to his role as the chair of UWA Institute of Agriculture Industry Advisory Board, Terry was recently appointed by the minister as the inaugural chair of the new industry peak body of the whole Australian grains industry. Congratulations, Terry. And when he got the thing, I just took the phone and said, yes, you're going to bigger and bigger things, but please remember to stay on board on our UWA Industry Advisory Board. He said yes, so he will stay. Thank you. Terry has more than 40 years of experience in agriculture and has held numerous high-profile positions, including the former chair of the Grains Research and Development Corporation board chair, and I used to work under him as a panel member, the Australian Life Export Corporation, and the current chair of the Australian Exports Grain Innovation Centre. The type of work Terry has done for Western Australia, and the University of Western Australia, the university gave him the honorary doctor in agriculture science, the first farmer ever get an honorary degree in agriculture science. So with that introduction, I welcome you, Terry, and you can do the job. I'll sit and relax. Thank you.
Wow. Thank you, Professor Siddique. I don't know whether Rosanna got that photo, but that was actually a photo of cattle in a feedlot. I just got in the way. But look, thank you, Professor Siddique, for the introduction. It is a privilege to chair the Industry Advisory Board and to have a role here in assisting the Institute of Agriculture in its mission. It has been a great piece of work over the last few years, and I've thoroughly enjoyed it. But the Vice Chancellor, Amit Chakma, welcome, and I acknowledge your presence. I know you're going to open it shortly. But firstly, can I say a few words about the Institute of Agriculture Advisory Board? It does play a critical role in the Institute's strategic direction and particularly the interaction with industry. The board is made up of farmers, representatives of the agricultural industry, including WAMCO, CSIRO, the CBH Group, CSBP, Intergrain, the Australian Agricultural Consultants, farmers and the Department of Primary Industries and Regional Development. The Advisory Board provides some advice and support to the University and the Director to enhance the value of the Institute, to realise its mission to benefit rural and regional industries through research, training and development. It also serves as a good avenue for the industry to undertake the work of the University does through the Institute. And one of the things we do, as Professor Siddique said, is run this annual forum each year. And you've seen the list of topics that have been covered in the last 14 or so years. We chose this year to look at climate change in agriculture, challenges and solutions for Australian farmers. We wanted to concentrate on, not get into a polarising debate on climate change per se, but to look at what we're doing as agriculture and how we work with it. And we'll have a number of speakers who will cover that topic, and particularly final two speakers to practising farmers who are actually working day to day in this business and understanding just what they are doing in terms of adaptation and how they're adapting their business to maintain productivity over that period. So with that, before we go on, it usually gets forgotten, but I want to acknowledge the hard work of Rosanna, Diana, Siddique and his team, bringing this together, getting speakers organised, and particularly the challenges this year with the restrictions on travel, etc. I just acknowledge that they've done a lot of work to bring that together. So I thought I'd just raise that up front because they quite often get forgotten at the end. So thank you, Rosanna, particularly, who's taken a lead in this. But now, look, it gives me great pleasure to invite Professor Amit Chakma to deliver the introductory remarks and formally open the conference for 2020. Professor Chakma joined the University of WA as its new Vice Chancellor in July this year, having previously served as President and Vice Chancellor of the University of Western Ontario from 2009 to 2019, I think. Prior to his tenure at Western, he was Provost and Vice President Academic at the University of Waterloo from 2001 to 2009. In addition to his university leadership roles, Professor Chakma has served as Chair of the Council of the Association of Commonwealth Universities. He was Acting Chair of the Board of Trustees of the Asian University for Women and chaired Canada's Advisory Panel on International Education Strategy from 2011 to 2013. a very long career in a number of areas, and I know he's welcomed the opportunity to come to Western Australia and lead this university. So would you please join with me in welcoming Professor Chakma to open the conference. Thank you.
Thank you, Terry. Before I begin, let me make a comment. Professor Siddique was making reference to the clock, so I'm getting to know him. He's a punctual man. He showed up on time, but I beat him. I showed up before he did to show my commitment to the Institute. And I believe that I earned lifetime recognition. So next time, if I don't show up, I think my credits will carry the day. The second thing that I told Kadambot was he was trying to fix it. I said, well, we are a university, highly bureaucratic. I'm pretty sure many of you will recognize that. I said, there must be several policies you have to follow before you can touch the clock. We are trying to change that. We're trying to make us more nimble, agile. So hopefully the joke I told you is not a reflection of how we do it, but if it is, we're going to fix it. It is my great pleasure to welcome you to my new home, this wonderful university, a wonderful campus, on a sunny afternoon. You have figured out that I came from Canada, so this is a different climate in Canada. So winter is just knocking at the door. A friend of mine sent a picture from Calgary, Alberta. It's full of snow there, so I can just rejoice the beautiful weather that you all are so accustomed to, and we are just enjoying every moment of it. Coming to this university, this is a great university. I'm honored and privileged to have the opportunity to serve as its Vice Chancellor. A little bit of history is always good for new Vice Chancellors to learn something about the institution they're trying to lead. This university was founded in 1911. And what is even more important is that we are founded to advance the prosperity and welfare of the people. I've been in the university world for many, many decades. I don't know of too many universities who actually have this special task to serve the people of this great state. The only parallel I can draw in terms of legislative mandate would be North American land-grant universities. So that notion is quite well established. So that's where the similarity is. We at UWA, we take that charge seriously. I, as new Vice Chancellor, I'm inspired by that mandate. And what a wonderful way to begin my tenure here. My day one at the job was to participate in a similar event where we are looking at Australia's defense policy. So that's the notion of service, how universities can serve. And today, of course, is agriculture. When we were founded, it was understood that agriculture was one of the, quote, practical arts and liberal studies, end of quote, needed to fulfill our mission. So we looked at the needs of the state, and we concluded that as the university of the state, we actually have to link our thought processes, our activities to the real needs of the state. And of course, agriculture is a big part of it. Agriculture then was most definitely a practical art. Those who founded this state, if that term is appropriate, those who started the agricultural sector here, they struggled, as we all know. It was indeed a practical art. How do you make use of the land here and then make it viable? It is not only a practical art, one might also call it a craft. And of course, along the way, we learned, we gained knowledge, and it served a very useful purpose. By 1911, the gold that had been here for the taking by eager amateurs was largely gone. So gold is gone. Now another parallel comes to mind, gold rush in California You can just see that parallel. It was clear that a lot of effort and expense would be required to get the rest. In that effort, this university contributed. Of course, that's through mining. We educated mining engineers who kind of managed to get the last, bit of gold out of our mines. Then comes, of course, agriculture. Agriculture was easier than mining. Not simple, not that easy, but nevertheless easier than mining. Agriculture yielded wealth more easily, or so it seemed. By then, there were 1 million acres under cultivation. The land was rich. Surely it would provide all that was needed. When it was suggested that Western Australia needed a university, there was considerable opposition. Of course, today, I cannot think of a community that would not like to have a university, and in fact, we are privileged to have 5 of those. Now, those of you who think 5 is too many, I kind of take the opposite view. Universities were described by some within the community as luxuries for snobs. Some may still think this way. I hope they're in the minority. Most, however, know better that universities enrich us all. You have just heard from our very distinguished Hackett Professor of Agriculture, Professor Kadambot Siddique. And obviously he'll have more to say. Others will have more to say. Sir John Winthrop Hackett, our first Chancellor, deserves all the honoring of his name we can give him. He was the beneficiary of university education in his native Ireland. And when he arrived in Victoria and then taught law at Trinity College at the University of Melbourne. It's all product of his university education in Ireland. When he arrived in WA, he tried his luck on the land, up in the Gascoyne district, and learned firsthand that the land does not yield its wealth that easily. In 1887, he became the editor of the West Australian, where he served as an early advocate for votes for women and as a passionate advocate for universities. So that's a little bit of our history. His idealism still is alive at our university, along with our determination to be practical, daily help to the people of this vast state. Our Institute for Agriculture, as you heard, works with agricultural and natural resources management sectors to create knowledge and improve skills under the guidance of our advisory board. The Industry Forum brings together members of agribusiness industry, decision makers and leaders, farmers, researchers, students, to discuss important topics immediately affecting the sector in our state of Western Australia. And it is the western third of Australia, of course, we all know that, and is a vital part of the global agricultural community, which we may not readily think of, but we actually are a major contributor to the global food supply. I'm a stronger believer in the high purpose and the effectiveness of institutes like the Institute for Agriculture. Universities, by design, unfortunately, we have created silos based on artificial boundaries, and institutes help us bridge those artificial boundaries. So institutes are extremely important in the life of our university, and they are a very important tool for us to be able to contribute and serve the mission that our founders set out for us, for the prosperity and well-being of the people of WA. So I'm a strong supporter of this institute because of what it had done over the years and what it will continue to do in the years to come. It fosters innovation and adaptation underpinned by scientific research, training and development. This allows it to deliver tangible outcomes and benefits for stakeholders. When you think of stakeholders, often we think of a narrow group of people who are directly involved with a particular sector. Well, that is probably not the best way of describing stakeholders that we are talking about in terms of the impact of agriculture and Institute for Agriculture in particular. What do you mean when you say stakeholders? If you look at impact of agriculture, we all are stakeholders. We all are stakeholders. You know, our survival depends on availability of food, which we take for granted, certainly here in Western Australia, but in many parts of the world that is not the case. And even if food is available, safety is not guaranteed. So there's so many different factors. Of course, you know, we are here to hear from our experts, so I thank you for your contribution. But it's beyond the expertise that we have through the university and other experts. I think what is even more important is for us to return to the basic premise I made. Agriculture is a practical art. We actually have to listen to our practitioners as well. So again, that Industrial Advisory Board Institute kind of connects all those different pieces. I'm indeed very grateful to you, Terry, for your long affiliation, and all the members of the advisory board, 14 years of service. That's remarkable. So typically, you know, when people sign up for these sort of things, including yours truly, they will typically sign up for 2 or 3 years, and then we move on and do something else. So I'm impressed, I'm amazed, I'm grateful for your long-term commitment to our Industrial Advisory Board. Without your guidance, I don't think we can fulfill our mission. We can do something, but it will not be as impactful as, you know, what it is today because of you. The board supports our leader, Professor Siddique, through policy and direction to enhance the value of the Institute and, of course, of the university as a result in the regional, national, and international context. That is how universities best serve the communities and advance prosperity and welfare of the people as mandated by our founders. So let me congratulate all of you for all the things that you do and for helping this university to fulfill its mandate given to us by the legislature of Western Australia. So enjoy the rest of the day. I must apologize, but for a very good cause. I'm not supposed to talk about it, but I'm going to talk about it without quite telling you everything so that I can say that I haven't revealed anything confidential. This is a great day for UWA, not only because of what we're doing here, it is a great day for WA. Later, a couple of hours later, I'll be participating at an event where one of our colleagues is going to be receiving a major recognition. So I gave you part of the story, but I didn't tell who the recipient is, what the recognition is. So as far as I'm concerned, that those of you who are lawyers, you may have different opinion. I don't think I have violated any confidentiality. So that's my excuse. So I do apologize. I'll be leaving this room so that I can attend the other event. Thank you very much.
Thank you, Vice Chancellor, for opening the conference and those words of encouragement. I think we look forward to a long association with the Vice Chancellor as he works in this university, and it's nice to hear him express strong support for the Institute model, which we're all helping to work with. We'll now move on to the presentations for the day, and the first presentation, if I can, there's some light. Dr. Stephen Crimp. Dr. Stephen Crimp is Research Fellow at the Climate Change Institute with the Australian National University. Stephen has more than 2 decades' experience designing, implementing and managing research to improve climate risk management for national and international primary industries. He's been a contributing author and expert reviewer of the Intergovernment Panel on Climate Change. Although Dr. Crimp is unable to present, obviously, because of travel restrictions, he has very kindly recorded his keynote address, and we'll play that today, and explores the topic Climate Change Challenges for Australian Agriculture. So, can you please welcome Dr. Stephen Crimp?
Thank you, Dr. Enright, for that introduction. And thank you also, Professor Chakma, for your opening statement today, setting the scene for this day of climate change presentations focused on the challenges facing Australian agriculture in the future. Today, I'll be setting the scene for you in terms of looking at the historical changes that we've seen in climate and attributing the changes in agricultural production that we've seen to those historical changes. I'll also be talking about the likely future projections and the likely impacts that that will have on Australian agriculture as well. When I give these presentations, I do like to start with an animation of global monthly temperature anomalies, because I think this really gives us a sense of the extent of change that we've already seen in the historical record. So what you'll see very shortly when I press the animation button to start is the monthly temperature anomalies. So these are departures from a long-term mean from the period 1880 right through to almost present day. What you'll see is, you'll see in the earlier part of the record both warm and cold monthly anomalies, and as the animation progresses you'll see that there is a change, and a significant change, in those monthly temperature anomalies. So I'll start the animation now. So, as I said, in the earlier part of the record, you've got a balance of cold anomalies and warm anomalies. But as we move through the historical record towards the present day, what you do see is that the frequency of those cold monthly anomalies starts to decline, the size of those anomalies starts to shrink, and the size and frequency of the warm anomalies start to increase. And so that when we get to the most recent part of the record, you can see there that there's only 1 month in that entire period where the monthly temperature anomalies at a global scale are slightly below the long-term average. And you can see in some instances, particularly in the most recent decades, that the average temperature anomalies at the monthly scale are in excess of 1 degree, 1.5 degrees, in fact in some instances we're almost 2 degrees warmer than the long-term mean. So what we can see is that there's been significant change in the global temperatures. We've also seen changes in Australia in the same vein. And so if you pay attention to the top map on the left-hand side, this is a map produced by the Australian Bureau of Meteorology showing trends in the average temperatures. And you can see that over almost the entire of the continent, temperatures have been warming, and probably warming more significantly over the Australian East Coast region than the West Coast. 2019, though, was the hottest year on record in Australia, and that was 1.5 degrees warmer than the long-term mean. That in 2019 was a year that had several months with heat waves and several records, consecutive days with temperatures in the very high, sort of almost 41 degrees to almost 42 degrees. These consecutive heat days were actually records that were set last year. The other thing that's happened is that we've had a 5-fold increase in extreme heat events since the 1950s. And so a significant increase in this frequency of particularly destructive hot temperatures. In terms of the trends in Australian rainfall, on the bottom right-hand side of the slide, what you can see there is that both the West Coast and the East Coast have experienced significant declines in annual rainfall. And much of these declines are being driven by declines in winter and spring. In terms of temperature extremes, this map here shows you a comparison of temperatures in excess of 37 degrees Celsius and compares two periods. The first period is 1951 to 1980, and the second period is 2010 to 2018. And what you can see there is that almost the entire continent has experienced an increase in the frequency of days above 37 degrees. And we can see that in some instances, those increases have resulted in anywhere between 15 and 20 more days above 37 degrees over the most recent part of the historical record. So it's not just the extreme hot temperatures that we're seeing changes in, but we're also seeing changes in the extreme cold temperatures. And these two maps here show you the two extremes. So on the right-hand side, we have the occurrence of temperatures below 2 degrees at the Stevenson screen. And so we sort of define these as the starting point for which frosts can actually occur. And so if you look at the coloration on the map there, the blue areas show where those temperatures of 2 degrees are actually occurring later and later in the calendar year. And whereas the orange to red show where those extreme minimum temperatures are actually occurring earlier in the year. So what we can see is, despite the warming that's actually occurred in the historical record, extreme minimum temperatures are actually occurring later in the year. And in some instances, the actual frequency of those events has increased as well. But on the other side of the spectrum, the very extreme hot days, and these are temperatures above 32 degrees, what you can see is that the occurrence of the first temperatures above 32 degrees are actually occurring earlier in the calendar year. And so we have this situation where we have frosts occurring later in the year and these extreme heat events actually occurring earlier in the year. So if we're thinking about an optimal flowering window, we are seeing that that is actually shrinking. And some work by a colleague at CSIRO, Dr. Fernando Drecker, actually provides some estimates of the changes that we've seen in what could be classified as a sort of optimal flowering window. And you can see that there's very significant trends occurring across much of the southern parts of Australia, particularly in Western Australia. That trend is almost a shortening of the optimal flowering window by a day a year since 1970. And across on the east coast, similar trends or similar magnitudes of trends, but also slightly smaller trends, but also in that shrinking of the flowering window. Excuse me. So what impact has this narrowing of the flowering window actually had? We can look at this through looking at observational data, or we can actually look at this using model data. So the first map that I wanted to show you is the modelled information and model data for wheat production across the Australian wheat belt. And this is some work that was produced by a colleague, Dr. Svi Hockman, and his colleagues at CSIRO. And what it shows is the change in the sort of potential yields that have actually occurred since the 1990s. And this is based on responses entirely to climatic conditions. So in the model simulations, there are no nutrient limitations, there's no pest and disease. So what you're seeing here is the translation of the impacts of climate on production. And in the simulations, you can see that the potential yields have declined by about 27%. So on average from 4.4 tonnes to about 3.2 tonnes per hectare. Most of that is being driven by rainfall decline. So you can see 83% of those declines are attributed to the changes in rainfall that we've seen historically, and 17% are in response to both the increase in frequency of the minimum temperature extremes and the maximum temperature extremes, so the heat and the cold. But we can also look at the impact in a more aggregated way, looking at the observations. And this is some work by colleagues from ABES, and what it shows you is the impact of the climatic conditions that we've seen historically on broadacre agriculture. So this isn't just an individual crop, but is looking at a range of broadacre crops across the cropping belt. And very similar pattern of decline as presented in the simulation data in the previous slide. But you can see over the period 2000 to 2015, the production of broadacre agriculture has declined by, in some instances, in the very dark red areas at the top of the sort of Western Australian wheat belt, by as much as 20%. Because of the changes that we've seen in historical climate. But you can see across the entire wheat belt there have been changes of the order of between 2% decline up to that 20% in the very dark red colours. So in response to those changes in historical climate conditions, we've also seen geographical shifts in the areas in which cropping is actually undertaken. And in this map, which is also produced by Neil and his colleagues, it shows the density of cropping that has actually occurred on average by comparing those two different periods, 2000 to 2015, against that 1989 to that 2000 period. And so you can see that what's happening is those blue areas are where cropping density has increased, and the red areas are where the cropping density has decreased in response to those temperature and rainfall changes. So just to recap then, we've seen that there have been some very significant changes in our historical climate, and that has already resulted in some significant impacts on Australian agricultural productivity, and that I've hopefully sort of shown you in terms of the previous few slides. What I wanted to do now was actually talk about the future, and to give you a sense of the extent of change that we might expect to see by 2100. And so this sort of rainbow diagram here actually tries to capture the amount of temperature change and associated emissions historically, which is the sort of black squiggly line that you see on the left-hand side of the graph. And then the sort of rainbow array of colours shows you the likely emissions pathways or representative concentration pathways, and the resultant temperatures that those RCPs might result in by 2100. So unfortunately, our current trajectory, where we're currently tracking, is on the RCP 8.5, so that red trajectory at the top. And that, as you can see, commits us to almost, well, anything between 3 and 5.5 degrees, or almost 6 degrees of warming by 2100. If we think about the Paris Agreement commitments, so those voluntary commitments, if every country were to actually adhere to those voluntary commitments, which they're not at the moment, then that might bring the actual temperatures down to anywhere between 2.5 to almost 4 degrees of warming. And many of you have probably heard of the sort of threshold that many scientists are talking about, trying to cap warming at 1.5 to 2 degrees. And you can see that in order to do that, emissions would have to drop considerably over the next few years in order to keep us below that 1.5 to 2 degrees Celsius target. So where will we end up in the future? Well, that really depends on our trajectory of emissions going forward. At the moment, we are on the very top end of that those emission trajectories, but if there is collective action taken at a global scale, we may be able to successfully bring those emissions down, but where we actually get to really depends on the extent of action. So if we think about the likely temperature changes we might see across the globe, the way that we do this is by looking at or using climate models. And our global climate models, if those are initialized with those different emission scenarios, they provide us with different rates of warming, different rates of rainfall change, and other different climate variables for the future. These two maps here show you the likely global temperature change if the RCP 8.5, which is the trajectory that we're currently following, is continued out to around 2030 and to later in the century, near that sort of 2090 or period. And if we look at the short term for Australia based on this sort of consensus of warming, we see that temperatures could be, by 2025, could be another 0.5 degree to 1.5 degrees for an RCP 8.5 emissions trajectory, or they could be up to 4.5 degrees warmer. So that's in addition to what we've currently experienced. If we look at the likely temperature change, rainfall changes, this map here shows you the consensus from a range of different global models, but it expresses the change in precipitation as a percentage per degree of global warming. So this map would suggest that for every degree of global warming, Western Australian rainfall may decline by anything from, say, 4 to about 6 or 7%. So that's for every degree of additional warming that we see. And what you can see is that there are some regional sort of winners and losers, if we want to define it in that way, in terms of rainfall change. So the southern hemisphere tends to be a region where rainfall declines over most of those continental land masses. And so agricultural production in the southern hemisphere certainly will become a more challenging prospect. These maps here show you the likely changes in rainfall and in drought conditions. So these are produced by the CSIRO. And the left-hand side map shows you the likelihood of increased incidence the left-hand map shows you the change in rainfall patterns and shows you where there is confidence that both winter and spring rainfall will decline, so those areas highlighted in that sort of orange colour. And on the right-hand side shows you the frequency of drought conditions, and the orange shows you where there's a sort of a medium confidence that there will be an increase in the frequency of droughts, and the red is where there will be significant confidence that future drought conditions will increase in frequency. So if we take these temperature and rainfall projections and try and understand the implications for agricultural productivity both globally and in the context of Australia. We need to use crop models or economic models that give us a sense of what those impacts are. This is a sort of a set of aggregated results for a range of different crops across the globe, and shows you that in response to the southern hemisphere sort of rainfall declines, that agricultural productivity is likely to be lower across much of the southern hemisphere, and that's of the sort of order of 3 to about 7% for the sort of mid part of the century. In the northern hemisphere, the prospect of increased production is simulated because of the removal of some of the temperature constraints currently existing on crop production. A detailed analysis by ABARES, this is a slightly older analysis now, but one that's relevant for the Australian context, shows you the impact of future changes in temperature and rainfall on wheat production on the top left-hand side, sheep production in the top right-hand side, and beef and wool production in the bottom left and right, respectively. The sort of the coloration scheme, or the colour scheme, any colours that are pinks through to sort of reds and browns, showing where declines in productivity are very likely. The blues and greys and blues show where productivity potentially could increase. But I think what you can see there is that without significant adaptation or change, the agricultural production in the context of Australia is going to be more challenging in the future. So the question is, how do we begin to establish adaptation strategies for these changes? And at the moment, our focus has really been on trying to ascertain what the future changes in rainfall and temperature and crop suitability, etc. will be. We've also looked at sort of biophysical modelling, but what is missing from the development of these adaptation strategies and scenarios are more effective economic analyses to show what the impacts are of climate change with and without adaptation. But most importantly, we need to understand what the social ramifications are for our Australian farming communities. And we really need to do that in order to build the resilience of those communities to future climate change. And so all of these different dimensions are very, very important if we are to establish successful adaptation strategies going forward. When we think about adaptation, I think we need to see it as a sort of set of a hierarchy of options, and we talk about tiers of adaptation. So at the very lowest tier, we talk about this as incremental adaptation or incremental change or tactical change. So these are really small modifications of existing management. And some examples that you can see there are things like changing varieties or changing planting times or row spacing or looking at stubble retention or different ways of managing water. So these are all fairly small changes to existing practice. They are a lower risk, they're usually of a lower cost, but the problem with those is that they're successful for fairly small changes in temperature and rainfall, but become less successful as we move towards more extreme changes in both temperature and rainfall. So to cope with those more extreme changes in the projected rainfall and temperature, we need to think about the systemic or transformational adaptation options. These are more expensive, these are more risky, but they're likely to give us resilience to the larger or more extreme projections of rainfall and temperature that I discussed earlier. So the question that I'm often asked is, how much time do we have for action? And we have a very strong, almost linear relationship between the emission scenarios, the rates of accumulation in greenhouse gases, and global temperatures. And so what we can start to do is extrapolate the existing trends in the emissions and to give us some sense of when we might meet or surpass critical temperature thresholds. So if we say we have a 1.5 degrees Celsius goal and we want to cap emissions to prevent us from exceeding that goal, then we can use the sort of linear relationship to actually work that out. And so if we want to have a 50% chance of keeping temperatures below 1.5 degrees Celsius until the end of the century, we can only emit a further 480 gigatons of CO2, and that's from 2018. So based on the current rate of emissions, that really only gives us 9 years or a decade before we have to take some very significant and decisive action. So we could think about using this current pandemic as a catalyst for either thinking about how we start to try and address our emissions trajectories in a significant way. Otherwise, what we will see is, as our economies recover, we'll see that the emissions then continue and recover in terms of their trajectory very, very quickly. So we have an opportunity now to think about how we might, at a global scale, try and tackle the issue of greenhouse gas emissions. So just to conclude my presentation, what I hope you've taken away from the presentation today is that climate is already changing. It's changing here in Australia and globally, and more change is certain. We're seeing a range of climate variables change in directions that make agricultural productivity more challenging, or maintaining agricultural productivity more challenging. And those changes in extremes that we are seeing are ones that have significant impacts on our productivity. So I think a priori, what we can say is that given the historical trends and the future projections, agricultural production globally and in the Australian context will be far more challenging. And these are challenges that we can begin to address both through managing our emissions, but also through adaptation. So there's both mitigation and adaptation that will be the solution to this significant challenge. So I thank you for your attention, and I wish you success for the rest of the day. Thank you very much.
Well, thank you, Dr. Crimp, and Stephen will join us on the screen at the conclusion of the day when we have the panel discussion. So thank you very much. Moving on. So to our next speaker, someone who will be well known to me, is Dr. Phil Verko. Phil is an animal-based scientist based at the University of Western Australia, who is the Associate Director of the UWA Institute of Agriculture. His research interests range from manipulating microbial fermentation in the rumen through to ruminant production systems more generally, and finding ways to balance productivity with biodiversity and looking at extensive grazing systems. He will be speaking on emissions from ruminants, the role of Australian native plants in reducing methane. Interesting topic. Can you please welcome Dr. Phil Verko? Thank you.
Thanks, Terry, very much. And Rosanna, I don't know where you get these photos from. That was a photo of a shrub that I got in the way of. And, and thanks, Siddique and the advisory board, for giving me a chance to talk today. I can't tell you how nice it is to be seeing people face to face. For the last 10 months, I've been looking at screens, and I was half expecting people with black boxes and their name written across them to be sitting in the audience. It's just wonderful to see faces looking back at me. So thanks very much for coming. Yes, so I definitely will be trying to move this along. There we go. I wanted to start with this quote by Richard Norton, who at the time was the Managing Director of MLA in 2017, about an aspirational goal that he announced that to try and get things right to get the Australian red meat industry to be carbon neutral by 2030. So that's a massive challenge for the industry, but it was a bold statement and now recognised as an aspirational goal, which I think is fantastic. And I think, where are we going here? To the right. Maybe I need to be closer. Maybe I need to be closer. There we go. I'll stand a little closer, Roseanne. Sorry. And what we'll need, or what I'll try and demonstrate today, is that we'll need a combination of methane mitigation and also vegetation management to try and achieve these goals. It won't all come from just trying to reduce methane emissions, but to do that, I'll go through and chat about a number of things. First, where do livestock fit in the national emissions? A bit about methane production. I'm a little bit sick, probably. I love the rumen and the rumen system, which probably seems a little bit odd, but that's the way I am. So I need to tackle that a little bit to fit you into the picture of why we're interested in Australian native plants and their methane emissions. So let's say, depending on which year you read it and which article, let's say about 14% of the national emissions come from agriculture. And if we look at that, we've got a range of contributors, if you like, to that 13-14%. But a large one is this 70.6% is due to enteric methane emissions. So that's the emissions that stem from what I'll be talking about at least is a rumen system. So 10% of all Australia's emissions stem from these enteric methane emissions. So it's a challenge for us. It is something that we've got to address. And so what I'll try and chat to you about today is at least one possible way in which we can try and reduce those emissions. And if we just look at this, you can see that if we look at the various possible sources of those emissions, the northern beef industry is a big contributor, the dairy, cattle, sheep, and then it drops off thereafter. So ruminants are a key contributor to those 10% of the national emissions. And where do they come from? So let's talk about this rumen. I've picked on the sheep, but just as a representative of a rumen, feed goes in, feces come out the other end, and in the middle, it passes through this rumen, what we call a rumen. And for many years, it was considered a bit of a black box. We didn't quite know what was going on there. At this stage, we know a little bit more about what goes on in there. And I'm going to explain why I think we need to probably challenge ourselves by understanding more about it still, because it's a key to being able to manage the emissions from these ruminants. It's a complex microbial soup, and it ferments the feed that comes into that the animal consumes. It ferments that feed. It's where it drives the energy of the animal, but it is also the source of these emissions. And we know more and more about these this microbial ecology. These are protozoa that you can see, but there's bacteria, there's fungi, methanogens, obviously. And so it's a really interesting but complex soup, and it's highly adaptable. And we should be interested in it, not just because I think it's fascinating, but we should be interested in it because it's the source, it really is the interface between the feed and the animal. Yes, there are, the lips and there's a lot of stuff that happens prior to ingestion. But once it hits the rumen and it hits this microbial community, and that fermentation is the source of the energy and protein needs of the animal. It's the source of methane and ammonia, and it is also can result if there's an imbalance there. So if we get it wrong, it can be a source of complications like bloat and acidosis, and it can certainly influence the worms and the health of the gut, if you like. And if we look at those things, that rumen is driving production, it's driving waste and pollution, and it's driving health of the animal. So all of these things, if we think about clean, green and ethical, all of these things are in the targets, and all of these things have been influenced in some way by rumen fermentation. So understanding a little bit more about those microbial communities and how we can manipulate them is actually quite a useful thing to be doing. If we focus in on methane, then somewhere between 2 and 12%, depends on the diet and a number of different things, 2 to 12% of the energy that the animal consumes is belched out as methane. Every single article that you see, they say the animal farts the methane. It's not the case. 95% of it is belched, eructated. There is some small percentage that comes out the other end. But so that's all of this energy, 2 to 12%, the animal spent finding it, it's kissed goodbye as methane. So why not capture that energy and divert it into something useful and reduce greenhouse gas emissions at the same time? So we get a dual benefit if we can change that fermentation towards one where there is less methane produced and more useful products. And at the end of the day, the methane story is much more about hydrogen utilisation than it is so much about methane. It's trying to capture the hydrogen and redirect it into more useful pathways, of which methane is one, but it is possible to manipulate that. So, we've got a few options. We can reduce methane emissions directly, so we can target and try and focus in on the methanogens and the microbial community and try and drop total emissions. We can improve emissions intensity. So in that situation, all we're saying there is that per unit or per kilogram of product, whether it's meat or wool or milk, it's how much methane is generated for that kilogram of product. And so that's an emissions intensity. So I could tell you just about anything that improves efficiency on farm of production will be an improvement to emissions intensity. And we can also manage our grazing to retain and build carbon in the landscape. So we can tackle it from the methane directly or through improved efficiency, and we can also keep more carbon in the landscape. And they're the sorts of things that we're going to need to be able to do to have an influence and an impact on this aspirational goal of trying to reduce the footprint of ruminant livestock. Sobering talk, the first one, and this is just a graph. We've taken it from the bomb site. All it's showing is that between December and April, the December and April rainfall, so we're in a Mediterranean climate. This is the target for this talk, is a Mediterranean climate. And this is just shows the percentage of that year's rainfall that fell between December and April. So in our world, that's out of season over the last 100 years. Now, that to me is an interesting story in itself. But what we really are aiming for, and it sort of matches the story in the first presentation, is that we do need to be able to have versatile systems, flexible systems, adaptable systems, because we want to be able to cope with years like this, and we want to be able to capitalise on years like that. And that's where the shrubs and the Australian native shrubs come into the picture. So I've broadened the whole talk out. I know it was about Australian natives and methane, but it's a bigger story than that. Methane's just one part of where Australian native shrubs can play a role. There's a number of other things, but it is a system that can help us capitalise on those good years and cope with the poor years in what is obviously a highly variable system. And this is down at the University Farm, down at Ridgefield, and we planted shrubs. It was part of a research project looking at the capacity of shrub systems to improve emissions, and particularly emissions intensity, but we're also interested in total emissions. And this is the way in which we decided to manage them. We had 10 different Australian native shrubs. I won't go into the detail of the design, but basically we had rows of shrubs, and importantly we have inter-row species that complement those shrubs. And we're interested in this because it is a system. And so these shrubs, as I said, I've got it right down at the bottom here, the bioactivity, less methane. It's not 9th because that's the priority. It's just that there are a number of valuable components to having these perennial shrubs in our system. In a Mediterranean climate with variable rainfall, hot, dry summers, getting perennials into the system can give you a number of benefits, all of them that contribute to livestock productivity, but also can influence the methane emissions. So, green nutritious plants, drought resistant, drought responsive, areas not suitable for crops, a variety of benefits, less feed supplements, biodiversity, shade and shelter, increased reproductive efficiency, carbon storage, and we'll talk about this less methane component. I'll focus in on that. Excuse me. And the Enrich project that was part of the Future Farm CRC actually won one of the Australian Museum Eureka Prizes in 2013. And the lovely thing from my perspective about it all is that it's not just the bioactivity, which I'll go into in the next slides, but we've got methane mitigation capacity, vegetation management and adaptation in a system that includes and involves some of our Australian native plants. If we look now just at that point number 9, I have to be very close to this, Rosanna. This is just a set. We went and screened about 120, it's more than that now, but initially it was about 120 of our Australian native shrubs. Most people, when they'd considered Australian native shrubs in the past, had focused in on one species in the hope of like a silver bullet approach. And you can't do it that way. There's always a complication. These plants are unbred, still full of plant secondary compounds, and that's the value to us. And what we can do in the lab is actually take rumen fluid from a sheep or cow. We use sheep rumen fluid, and you can look at how much methane is produced. So it ferments in a bottle over 24 hours. It can be over 3 weeks. There's different ways of doing it. And you measure the total gas production that fermentation produces. So we get total gas, and that's a good indication of fermentability, so how fermentable, how digestible the feed is. It's actually a very good guide to that. And then what the proportion of the methane is in the gas that's produced. And we know that the more feed, the more gas. And the more digestible, the more gas. So we expected this sort of trend. So as the plant became the more fermentable the plant was, the more methane that would be generated. That's the expectation. So when we went in and we actually had a look at all of these Australian native shrubs and we put them all through the system, this is what we found. The crosshairs are actually just a relative control. It was an oat and chaff, just something that we could make a comparison against. And we did get that trend. You know, as plants were more fermentable, they tended to generate more methane. But depending on where you were, there was quite a dramatic difference in some cases where there were some plants that were highly fermentable, but less methane was produced for the amount of gas that they were producing. So for the same fermentability, if you like, there were quite significant differences in the amount of methane that was generated. And that was quite exciting because at the end of the day, you've got a lot of wobble around that line, and that wobble is scope. So if we're looking at having to, or interested in making choices about what we may or may not use in a diverse system, then making better choices is one way of going about reducing methane production. And there were some that were particularly interesting that were highly fermentable and low methane. Obviously, it was down in this little quadrant that we were most interested in, but it wasn't the sole thing that we were interested in. Because remember, these plants don't have to be 100% of the diet. And in fact, one of the most effective and anti-methanogenic plants we've ever found is Eremophila glabra. The other one, which isn't an Australian native plant, is Bicerula, a pasture legume. And they are by far the most effective plants we've seen in terms of reducing methane production. And we had a PhD student who used the animal house and chambers, and we found that if you included Eremophila glabra in the diet at 15%, you got 15% less methane. And that's handy because if you've ever seen Eremophila glabra, it's not a particularly big shrub. And we also know that you don't want it to be 100% of the diet because it actually has the effect of affecting the microbial community more generally, not just the methanogens or bugs involved in that methane production. So there's a more general suppression of the fermentation. But as a mix, it's perfect. So these Australian shrubs have the capacity to reduce the methane. They certainly don't have to be a silver bullet, and they can reduce methane production. When we tested that out in the paddock, so that was in the lab and then in the animal house, and when we used that site that I showed you earlier, where we had the shrubs down at the farm, that included Eremophila glabra, but it also included a number of other plants that had shown a whole variety of interesting features from a bioactivity front. And some of the others obviously also reduce methane production as well. But when we put it in and we looked at animals, the CSIRO had this wonderful, we used to call it the upside down bouncy castle, but it was basically a big inflatable tent where you can put animals through the tent in a grazing type scenario and measure methane from those livestock. And so when we did that, what we found was by grazing animals on these shrub-based systems, we had a range of interesting features, but in particular, we found that over that period of time, when we grazed them through the autumn, we had a 26% reduction in methane emissions intensity. Okay, so we were generating more product per unit of methane on these sorts of systems. So that was exciting to us. I think there's still more to be done to just try and figure out whether we're really picking up lower total methane emissions, but at least at this point, it's useful to know that we can generate less emissions per kilogram of product when we use these sorts of systems. What we need now is other solutions through other periods of the year, because at this stage, that's a defined period of time through the summer and autumn. So I think that, so I broadened it out. I wanted to put it into perspective because the Australian shrubs, it is a system of which part of it is this wonderful opportunity to use the bioactive components, the plant secondary compounds that reduce the methane to help us try and meet this challenge that Richard Norton set. And I think it's a system that allows us to try and tackle it not just from the perspective of reducing emissions directly, but also from a system that enables us to reduce emissions intensity, and also from a system that has the capacity to adapt to the needs of the variable climate that we have. So thanks very much. Thanks, Terry.
Thank you, Phil. It's a very interesting aspect of dealing with methane, much wider issue than just dealing with methane. I think that was very well put together. Thank you. Well, now, my pleasure to introduce Dr. Yvette Oliver. Yvette, who is a senior experimental scientist at CSIRO Agriculture and Food. Her work combines information from farmers, precision agriculture, sensors, soil science and simulated modelling. This is aimed at improving management decisions at the paddock and farm scale. And today Yvette will be speaking on water use efficiency and productivity improvements in the farming system. Can you please welcome Yvette? Oh, she's here. Thank you.
I thought Cool. So this is awesomely working. Awesome. So I'm going to talk about water use efficiency, and I was involved in the water use efficiency project that John Kierkegaard was a leader of. So I'm going to have to pretend I'm John Kierkegaard, although it's some pretty big boots to fill. So water use efficiency around in Western Australia, particularly in Australia, is actually a massive team effort of DPIRD, UWA, CSIRO. It is not just me. So I'm going to show work from all sorts of people today and acknowledge that without all of us, plus all the farmers and grower groups involved, a lot of this work on water use efficiency, we wouldn't be actually getting the gains that we are. So water use efficiency is kind of simple. It's rain to grain. Or if we're talking about in terms of like Ross's, it's actually rain to dollars, because that's the big ticket. You see a lot of people talk about it's the crop's capacity to convert water to grain. So you see it as kilograms of grain per millimetres of water. And water can be anything from including the stored water, the rain that grows in the season, and a whole lot of losses. So there's a whole lot of different ways you could calculate water use efficiency, so that if you wanted to look at on a farm within a year what sort of water use efficiency you were getting, and also having a look across seasons. But I'm actually just really going to focus on yield, because I think in this case it's a little bit easier to explain across seasons and across years. So I'm just going back to a little bit of the water balance cycle to explain where in the farming system the water is and where our gains are coming from and what sort of management options we're going to do. So what we've got here is you've got your summer rain, and it's going to be stored in the water. You've got your growing season rainfall, and again, hopefully stored into the water, and then it's transpired by the crop. But unfortunately, it's not that simple. A lot of the time, the water either runs off because we've got some non-wetting soils, or we've got issues with our surface. You've got a whole load of evaporations because it's very hot. You have weeds in your systems over the summer. They're using the water, and you've got drainage going out. And then also, early in the season, when your canopy is quite small, you've got, again, a lot of soil evaporation, and you've got some drainage that's occurring. So in West Australia, if you haven't really heard, we have a lot of problems with our soils. So one of the ways that we look at it is the soil's ability to store water that the crops can use is called our plant available water capacity, or bucket size. So we tend to talk about our bucket size a lot. The bigger the bucket, the bigger the yield that you can get. But with the constraints that we have in our soils, so GRDC funded our Soils Constraint Initiative. So we were looking at acidity, we were looking at compaction, you're looking at non-wetting, and there's also issues with sodic and salinity. So a whole lot of issues which are causing us to not be able to store the water in our soils. So what a lot of these initiatives and a lot of work that's been done is around, can I increase my bucket size? What can I do? So it's a bit like this diagram, and as some of you might have been out and seen some of the trials, they're a little bit like some grave digging. There's some massive work going on through Chris Gazy and Stephen Davies talking about liming, deep amelioration, mobile ploughing to do some of this work. You might have seen Ed Barrett-Leonard talking about sodic saline and putting gypsum and organic matter on. So a lot of these things have been shown beautifully in a lot of the field days lately. And to put that maybe in context, Stephen Davies gave a talk a few years ago about what yield increases he achieved by doing some sort of different ripping and ripping down to different depths and using different sort of machinery. So he summarised a whole lot of work that he'd been doing and looking at around 0.2 of a tonne increases with shallow ripping, and once you got down deeper he was getting around the half a tonne yield increases. Then if you started to do some more amelioration, you can get around the 0.5 to 1 tonne yield increases. And so what I had done is doing some modelling. So I use AppSim model, as people know it, which basically grows a crop with the water in the bucket available. And so I said, well, what happens if the roots could only grow to 20 centimetres? You're saying you're only going to get around about 0.45 tonnes a yield. So if you start to manage to rip that soil because you've actually got a compacted layer at 20 centimetres and you can get down to 40 centimetres now, you get an extra half a tonne. what happens if you do this massive down to 90 centimetres, which you might have seen some farmers doing up around Morwa, Mullowa and around that area, you can get that extra 1 tonne yield benefit. Or if you only had a little bit of it, you're getting an extra half a tonne. So this is sort of explaining, and we can run these sort of models across the different soils and across the wheat belt to give you an idea about what kind of yield increases you can get by doing this kind of amelioration to remove compaction. But of course, while you're removing compaction, they're adding lime. So they're doing something for acidity. So they're doing it for 2 reasons as well. A big one in Western Australia is non-wetting. So instead of it wetting up beautifully, we've got oils in our sands that just build up from our organic matter and things, from our plants, from our old eucalypts. And then the water just, instead of forming a beautiful wetting front, it goes down in pathways. So we're losing a whole lot of water down the bottom and out sideways instead of filling up the profile. And what that causes is patchy germination in a lot of the trials, but there was also not as much water in the soil. So your bucket's not full. So you get a lot of yield loss from that. So again, what sort of work has been done? So Stephen Davies has done a whole lot of work around different amelioration options for improving the infiltration into your soil to do with non-wetting. So they looked at sowing position, soil wetters, mixing up the soil profile again, so maybe this is the triple win of a non-wetting acid compacted soil, and doing some claying on the surface and then sometimes incorporating all of that in. So now we have a beautiful wet soil with hopefully a profile that's full and can be used during the season. So his work, so again, this is from a crop update paper of Stephen's from last year, where he showed the type of yield increases you got from just doing row sowing management, so around the half a tonne. If you were doing some of the soil wetters, whether you banded or surface applied, you're looking around the half tonne to 0.3 tonnes hectare benefit. And then once you start to get into the mixing and ameliorating and really ripping it up and getting your machinery into it, you can get from 0.25 to 0.8 of a tonne yield benefit. So huge increases in yield from a lot of cost. But he put that into a context. He said that often within 1 or 2 years, you're actually paying for that type of amelioration. So in terms of rain to dollar, you've got a bit of bang for your buck if you've got non-wetting soil. So now we're going to look at the beginning of the season. So this is where we're talking about you getting all this summer rainfall. And you have evaporation, weed water use, and runoff, so it's not stored as much. An example by John Pashura, what they had was they had a big rainfall event and they looked at what happened to the water over a 20, 30-day period after this, or 30, 40-day period. So the green line is if you had weeds, as expected, it uses a lot of that water and uses it very quickly. But the main one I'm interested in is the red and blue lines. So the blue line is bare soil. It just evaporated off. And the red one is if you've got a mulch, so you've got your stubble cover. After about 30 days, they end up around about the same. But the main interesting part is around that 10, 20 days. This is where there's actually more water in the soil by having your stubble. So this is important for when you're talking about sowing opportunities, deeper sowing, dry sowing. So it starts to become very important to retain your stubble when you're looking at our early sowing management. That's becoming really important now. And to put that in a seasonal context, we ran some modelling with the Liebey group. And we went and had a look at what sort of yield losses that you'd have over a sort of a 10-year period if you had lots of weeds and you had no stubble. So really poor management or something really went wrong. And so you can see, so that's the green line, where you're getting at least half a tonne or more yield loss because you had poor weed and stubble management. Then the blue one is where you had good stubble, you had a good yield before, you've tried really hard, but your weeds got out of control and you're still having a very significant yield loss in almost every year. So the years where, like 2005 and 2007, the weeds didn't germinate, so there wasn't actually any weeds growing to create the yield loss. And then you got the blue, which is they managed their weeds, but their stubble was gone. And so this is that story about the evaporation and the early sowing. So this is really just probably not showing you the full story, because this is where we use a sowing rule. It's sown, they're both sown at the same time, whereas you might actually have a 10-day earlier sowing because you've managed to put your stubble in and retain your moisture. So it would actually be a little bit different story. Okay, now we're actually in the middle of the season now, so we've sown our crop. We're actually about to sow our crop, and so we're talking about your sowing opportunities. So the early sowing, the dry sowing, what type of crop and variety you're going to choose to try and get into that optimal sowing window and miss the heat and frost, as Stephen was talking about earlier. Looking at things like sowing depth, there's some work on different varieties and sowing chickpeas deep to sow them into the moisture that hopefully will be available because you've covered it with stubble. Crop density and canopy management, so that's about reducing the evaporation early in the season. Nitrogen management, which is one of our big things about our yield gap. And in-crop weed management and disease management. So these are just more the usual agronomy. So some work by Chow Chen and Andrew Fletcher. They looked at when the optimal sowing window is. No, sorry, this is optimal flowering window. So once you find your optimal flowering window, you work back with different varieties to look at your sowing opportunities and the best time to sow and best varieties to sow. And so what they found is with long duration cultivars sown early, they will actually achieve higher yields under both the current climate and in the future climates like Stephen was showing. But this is probably more the short 15, 20-year climate, not the 50, 100-year climate that they were talking about. So it becomes really important to sort of understand what your flowering window is and how that's changed under these different climate conditions, so that you can then adapt your sowing time, dry sowing varieties to match our drying climate. And unfortunately, this is probably where my least amount of knowledge is around the genetics. So there's a lot of work going on in terms of improving the crops, how they partition the water and do their roots to basically grow better biomass or more yield for the water available. But there's a lot of research actually around matching it to our issues in our climate and our environment. So around the drought tolerance switches, trying to change the rooting pattern so they can access more of the water, or they're acid tolerant, or other sort of fantastic genetic work. And then one I'm probably more familiar is where they're looking at genetics to allow deeper sowing and increasing sowing opportunities. So Greg Verbretzky's team, along with DPERD, are looking at dwarfing gene and long coleoptile wheat. So one of the successes, I guess, is that this is a real integration with a grower. So Callum Wesley in Southern Cross is very integrated, running these trials, is very excited about the ability to sow deep into moisture because you've got a change in the variety. So then, again, so this is now we're starting to go, I've shown you the beginning of the year, the middle of the year. Now we're going to look at what about the previous season. So we're starting to talk about this in terms of a system, not just about a single year or a single summer beforehand. And so this is where the story is about the long fallow, or what your previous crop was, or whether when you were soil ameliorated, things to do with the weed burden. So some example of this, I guess, is where some of the consultants were telling me they were doing their amelioration, and that when they'd run and grow a cover crop to get some nitrogen in the soil and cover their soil, then they would go make sure it was all weed free and go in with canola because they knew they would have lots of water. Then that's their second break from their crop break, so they had 2 years of weed and disease free, and then they could go on with their wheat for a few more years. So it was more about how they could grow it over a more number of years than just the single year. An example of this is also with long fallow. So some work that Rob Sands and I did, we looked at fallow in different locations, and I ran simulations to work out how many years you're going to get a yield benefit. So in Dalwallinu, where it's a little bit wetter, it was only like 30% of the years you actually got a yield benefit from fallow, whereas in Meredith it was 60% of years. that you got a yield benefit from a fallow. And the increase is around 0.6 up to 0.8 of a tonne's increase. So what Rob did was put it in context of a 10-year rotation and said if you had a 1 in 5 year of a fallow, it was as profitable as a pasture, or it was more profitable than a poor legume, which is a common issue, is our legumes aren't grown very well, so we don't yield as well. So again, putting it into a long-term system, you can see increasing both yield and water use efficiency by different management practices over a number of years. Beg your pardon? Oh, heaps done. I was going fast. So, even though Stephen Crimp showed this decline, this is some work that Andrew Fletcher and Chow Chen have done and looking at historic climate change and how it's affected the spatial distribution of water limited yield across Western Australia. So what this graph is showing is on the orange is where they've simulated the yield, the potential rainfall limited yield over 100 years. So this is a large number of locations and soils, so it's not just one location. And it's just sort of showing it's kind of going up and down, but it's kind of not this massive decline that they're showing. But then you've got where the wheat yields are increasing over time. So even though we've been told the climate is drying, you're getting this increase. And it's due to management interventions to increase water use efficiency. So originally it was around fallowing, improved pastures, and then it comes into herbicides, break crops, and fertilisers. And then probably the big one more recently is around dry sowing, and I've added, of course, soil amelioration, and some places a return to fallowing has become increased practice, which is increasing our yields. What I want you to notice is though there's still a gap. So you've got your potential yields and you've got your observed yields. So there's still room for us to maybe manage or get up to the water limited yield potential, which may not necessarily be the economic yield potential. So that is always something to think about. And so part of the work of looking at where the yield gap was part of the National Paddock Survey. So it was a project run over the previous 5 years, which had sites all across Australia's west, south and northern, where they were looking at to try and find out where was the yield gaps in our farming systems, so our losses, or where we weren't achieving water use efficiency. And so I removed all the stats because this is Roger's one. So I just showed the table, basically showing where our main issues were in terms of why we weren't achieving our yield potential. And so in West Australia, it's to do with our in-crop rainfall, so our distribution, our things about sowing, our issues about our soils. So it's our big number one. And number two is nitrogen. So we haven't quite got our nitrogen management as well as we think. And then number three, you've got your previous crops, so our rotations, our weeds, and we didn't have as much issues with diseases over these years and experiments. Whereas in the south and north, they're ranked slightly differently. But this gives us hope for areas where we may be able to try and improve water use efficiency using all of the things that I talked about previously. And to finish with the slide from the guru himself. So this is John Kierkegaard's slide. So it's basically summarising the work that we've been talking about and have been doing here, looking at the agronomic influence, the decisions that you can make, both strategic, tactical and remedial, how knowing your paddock history and what you're doing in the paddock can improve your water use efficiency. Looking at the previous year, things like the break crop, the spray topping, they talk about lucerne removal and soil amelioration. And then what you do in the summer with your weeds, your grazing, your stubble retain, and then what you do early season, your sowing, your varieties, your tillage, your stubble. And they're all to do with increasing the ability for the soils to hold and capture that water, reducing your losses from evaporation, and hopefully getting that early crop vigour. So hopefully, the words of John, this is how we can try and increase, with all the research going on, our water use efficiency.
Thank you, Yvette. Well, it's my now pleasure to introduce Professor Ross Kingwell. Ross is an esteemed Professor of Agricultural Economics at this university, the Chief Economist at the Australian Export Grains Innovation Centre, and Ross also manages a small group of economists in DPIRD and chairs the Australian Farm Institute's Research Advisory Committee. The title of Ross's presentation today on this topic is Climate Change, Australian Grain Industry Restructuring. Can you please welcome Ross Kingwell?
So obviously from what Steve was saying, this is Steve Crimp, the outlook for Australian agriculture is fairly bleak with respect to the climate resource that it will need to draw upon, in that our agricultural activity is going to take place in a warming, drying landscape. So if that's our future, as Steve also mentioned, we are looking at the prospect of additional drought in eastern and western Australia. So the focus of my brief talk today is to investigate what drought means. And I'm going to draw on a paper we published a few years ago. And what this research did was it tracked the same set of 240 farms in Western Australia's grain belt, and we tracked these same farms over a decade. And it was a decade in which drought did occur. It occurred both at a sub-regional level and even statewide. And what did we find when we examined these farms over this decade? No surprise that some droughts were worse than others. The drought in 2004, which in biological terms wasn't a particularly bad drought, was actually from a financial perspective very deleterious, because in that year grain prices were the lowest in a decade. So the combination of low yields and very low prices hammered those farm businesses. By contrast, the droughts in 2007 and the statewide drought in 2010 fortuitously coincided with a spike in international grain prices. So in revenue terms, when you multiply a low yield by a very high price, the revenue ramifications aren't as serious as you think if you view the landscape through the eyes of a biologist. Our results showed the truism that the more droughts that a farm business experienced, the worse was its financial performance. And the more separate droughts, that is, the more droughts that farm business occurred, but not in consecutive years, then the worse was their financial performance. But one of the interesting things we found was that when we examined farms that experienced 3 droughts over that decade, and yet of those 3 droughts, 2 of them were consecutive, and that was often the case in the northeastern wheat belt, where in 2006 and 2007 they experienced consecutive decile 1 rainfall years. Those farms at the end of the decade were actually better off than farms that experienced 3 separate droughts. And the reason why those farm businesses that experienced consecutive droughts happened to be better off at that decade of observations was the experience of those consecutive years of drought propelled those farm businesses out of sheep production. The cost of caring for and maintaining a sheep population on farm for 2 years in drought conditions marred those businesses such that they took a strategic decision to shift out of sheep production, and most of those farms have not gone back into sheep production. And yet that strategy of shifting out of sheep production at the end of the decade was the more profitable strategy. And what tended to happen over that decade, as a generalisation, was that farm businesses increased their cropping intensity. And that became a source of additional profit. Because during that year, or that period, were two sub-periods of spikes in international grain prices that helped deliver profits to those businesses. I want to move on and just talk about the 2010 drought and why it's important to establish the nuances in the drought story. This was a widespread drought throughout Western Australia that resulted in incredibly low yields. Either side of the 2010 drought were two favourable years, 2009 and 2011. And what I want to draw your attention to is grain prices for what's known as APW wheat and ANW. ANW is Australian noodle wheat. It's a wheat for which Australia is the sole global supplier. It's a unique wheat class that Western Australian farmers grow and deliver to Japan and Korea for the production of udon noodles. And because we are currently the single supplier of this wheat class into those two international markets, whenever we are in short supply of that class, there is understandably an upward pressure on movements of that, unlike APW. So in 2010, what you found was a price spike of $150 a tonne. That's equivalent to an additional 0.5 tonnes per hectare of yield for APW. So the market price spike delivered significant revenue to those businesses that were able to grow ANW. Now, ANW wheat is not grown throughout all of Western Australia. Where it is grown, typically farmers will have anywhere from 10 to 25% of their cropping program to that variety. And despite the drought conditions, those farmers that, though having low wheat yields, received significant financial benefit from the ability to grow a portfolio of wheat types, especially ANW. Similarly, 2012, which again was a poor year, and yet in that poor year, again, there was a $75 a tonne premium for the production and sale of ANW wheat. So despite drought being a deleterious biological phenomenon, it doesn't always perfectly translate into a deleterious financial calamity. I'm going to finish up by just telling another story. This time is the story about drought in Eastern Australia. If we're heading into a period of worsening frequency of drought, then provided droughts are not perfectly correlated across the country, that is west to east, provided those droughts are not simultaneous, then again this will be an important commercial opportunity for WA farmers. I'm going to unpick that story. If you take the East Coast drought in 2018-19, what this chart shows is for the states affected by a drought in Eastern Australia, The dark blue columns are their average production. The lighter blue is their production in that 2018-19 year. And the green bars are the regional consumption of grains in that year. And what I want to highlight is that those regions were in grain deficit, which is unusual when you think about Australia, and it's renowned for being a grain exporter. When you have a widespread drought, as occurred in that year, you actually, because of, remember, 75% of Australia's population is in those states. The other important story is over the last 3 decades, the consumption of meat has markedly changed. No longer is beef and sheep our main meats consumed, it's chicken and pork, and they are grain-fed meats. So consumers across Australia are consuming much more grain indirectly than was the case on a per capita basis 2 or 3 decades ago. So when you have high populations, when you have diets underpinned by grain-fed products, and you have drought, those regions become grain deficit regions. And they become opportunities for Western Australia. So in the last few years, we've exported over 5 million tonnes of grain out of Western Australia into Eastern Australia. Some years it's been our biggest market. So the future, second last slide, is this. If we were to replicate a drought of 2018-19 in 2030, a decade away, so that Eastern Australia was only producing the same volume of grain in 2030 due to the severity of drought that it did in 2018-19, then their grain deficit will increase markedly. They are going to have to import many more millions of metric tonnes of grain than was the case in 2018-19, because over the next decade there's going to be another 5 million Australians, and 3/4 of those are going to reside in Queensland, New South Wales and Victoria. And on current dietary projections, they are only going to increase their per capita consumption of grains. So that becomes an important opportunity for Western Australian grain producers. So my key points are really drought. Yes, it's very bad, but it's not as bad as you might first think. There are things that farmers can do through their portfolio of grains, through their technologies, that actually create better financial outcomes than you might think when you look out across the paddocks. And the other thing is that although drought locally is deleterious, a true hazard that needs to be managed, it's also a commercial opportunity when it's not in our backyard, but it's just across the way in Eastern Australia. So their disadvantage, unfortunately, becomes a great opportunity for us. To give you an anecdote, in 2018-19, in what we call the L1, L2 zone in Western Australia, those farmers on average had their highest rates of return over the last 30 years. 26% return to capital. 27%. In the M2 region, the top 25% of farmers in that year, their rate of return to capital was 33%. Phenomenal. So drought is not all bad. Thanks.
Thank you, Ross. Very positive spin on drought, which is nice to see. Thank you. I now welcome Dr. Meredith Guthrie, who has worked with the Climate and Weather Group in the Department of Primary Industries and Regional Development since 2003. She is responsible for the monthly statistical seasonal forecast and producing a number of climate-related maps. She is speaking to us today on climate change in the South West Land Division. Welcome, Meredith.
Thank you very much for the invitation to be here. It's quite an honour to represent DPERD. I'd just like to acknowledge Ian Foster over there and Fiona Evans, who, all their hard work, I wouldn't be here today. Thank you. So, following from Stephen Crimp's presentation and from the work from the Indian Ocean Climate Initiative, we do know that in the southwest of Western Australia we have had a climate shift since 1975, so the year I was one. We've had about a 20% reduction in May to June rainfall. And this has been because our weather systems, things like the subtropical ridge, have moved south. So that's since 1975. We've had a further shift since 2000. So this is a rather messy map, and it will be death by PowerPoint. Just if you guys want to go home now, it's for a good reason. So this green line here, that's the historical ISO height from 1910 to 1999. And since 2000, this is the growing season, May to October rainfall, it's shifted south. So a place like Muckamboodin now has to grow on use an average of 175 millimetres of rain in their growing season. So I'm not really allowed to look at future climate, but based on what Steve said, this is just going to get drier. Sorry about that. So if we look at, this is Mullawa, if we look at individual location, we can see that also the number of rain days that you are experiencing in the growing season, so April, May, June and July, the number of days of rain you get, now I've talked about rain days as being above 2 millimetres of rain, is reduced. So we're also getting a reduction in the number of rain days we have. Some locations, not necessarily Mullawa, we have seen an increase in the amount of summer rain you have. This is localised to the eastern grain belt. So a lot of people might talk about they've got more opportunities summer, but not necessarily for Mullawa. So you might have to look at it by a location basis. So the last 20 years we've had less rain. And we can see this in our Perth dam inflows. So this is the dam inflows in Perth, so that's the 1975 shift, and then the 2000 shift, and they're actually saying they've had a reduction, further reduction in the last 10 years, and I'm not going to go into talk about if that's because there's more clearing around dams. It's a bit controversial, so I'll just skip over that bit. I'm glad Ross talked about drought because according to the Bureau of Meteorology, we are currently in one and have been for the last 48 months. So this is the Bureau of Meteorology rainfall deficiency map. So they're actually indicating for the guys in the north and the bits in the green belt here, it's the lowest on record. So that's a bit of a concern. And we've also seen that in our stream flow. So this is the Hotham River near Dwellingup, so that's actually lowest on record there. So it's been a very challenging time. We have a trend of dry autumns, so March, April, May. The last 3 years have been quite challenging. This is a decile map that we produce thanks to Fiona's hard work. We've been able to produce decile maps. Now the dark red is decile 1 and the dark blue is decile 10. I only use historically baseline from 1975. I don't care about years beforehand because I wasn't alive then, and we don't get wet years like that anymore. So obviously it's been very challenging for up north. So we've had drier autumns, which usually mean a drier break. Whether or not they get summer rain is a key driver of whether or not they will sow, how early they will sow. And this is an example of a break of season map. This is for this year, and this highlights the variability of the climate in the southwest. So areas like in the south, they were lucky, they copped a mid-May break this year, but a lot of the other areas had to wait to the middle of June. When I talk about a break, I mean we're looking at 15 millimetres of rain over 3 days. Historically, we looked at 25 millimetres over 3 days, but it's very rare that you actually get an inch of rain in the start of the seasons now. So what does that mean in terms of averages breaks? So if you look at the long-term average break for a number of locations in the grain belt, they haven't changed at all much in context, really. If you compare the last 45 years to the last 20, they're about similar age. But there is a trend, especially for Mullawa and Meredith, that it is getting later. So the farmers might dry sow, and then it might have to wait for the seed to emerge with a good rainfall. So that can be a bit frustrating. And then they might get an event like what happened this year. We had a massive wind erosion event, and they actually had to reseed, which is also very frustrating and costly. So if we consider temperature, this is a thermal time graph. So it's cumulative day degrees. And here for this year, if we compare, this is 2020 for Ravensthorpe, and this is all the years from 1975, starting at the 1st of April. Ravensthorpe is actually the hottest it has ever been in terms of thermal time. And again, this is where it comes into how variable the state can be. For Pingelly, it's actually sitting on average. So what this means for Ravensthorpe, not only do they have a water deficient declaration at the moment, they've been carrying water all year, it also means that the crops that are in the ground are actually 2 to 3 weeks ahead of time. So if they're ahead of time, they're going to flower earlier, which means their frost window has moved, and so they're actually more stressed for frost and more stressed for heat and water, because their accelerated growth means they're going to require water sooner than if they were just growing averagely. You can tell I'm not an agronomist, can't you? Okay, so Steve talked about heat, and so we have noticed that the amount of heat during flowering in grain fields, so August to October, has increased. 2019 was a considerably hotter year. Not so much this year. We've been a bit lucky this year, but Mullawa did have actually, in May, they had a 30-degree day in May, so it's getting warmer. And in terms of heat stress, we have 175 weather stations that the department uses. We also have access to 332 bureau stations. Of these, not many measure temperature, unfortunately. So we've got about 70 plus stations that actually measure temperature since 2000. So if we look at those 70 odd stations and see when they've had a heat event in August to October, you can see that's actually increasing. So there's more stations are now getting a heat event than they have since 2000. And if you also look at the number of events at each location, you can see also that this is increasing. 2015 was a considerably hot year for the latest start of the end of the season, with Morawa and Mullawa had 32 events in 3 months, so that's really going to hurt your crop when it's trying to finish. In terms of frost, now this map that the wonderful, brilliant Fiona did for me, this is using CRIG data. So all these stations, disclaimer, all these stations don't record temperature. So those stations that don't are being filled, like interpolated data. So as you can see, if you compare the average in the purple, because I'm a Fremantle Docker supporter, I like purple. So these stations here had between 9 and 10 days below 2 degrees in August on average. And if you compare that average to the last 20 years, the area of 9 to 10 events have increased, and you're also getting locations where there's more than 10 in August. Now, I don't know if that is data alone or the fact that some of these stations are now recording temperature. So that's a bit of a question for Fiona for later. Again, for September, you can see that we've had an increase of the locations that are now getting between 5 and 6 days on average for frost. Of course, as well as rainfall and temperature, it's very variable. 2016 was a massive frost event, and that was because there was an area of cold mass came up from the south. We don't really want to see another one of these, but you never know, it could happen. Wickerpen North had 41 frost occurrences in 3 months, and there were reports of a farmer in Dandaragan who had never seen a frost before, and it just wiped out his crop. Anyway, some good news. Here's some good news. I'm not sure where Steve got his data, but this is a graph from Ian Foster, and it's actually showing that wheat yield on trend is actually increasing, even though we have a declining rainfall. Obviously, we're going to get massive variation between yields, but because of increased advances in genetics and technologies and farming that have had to adapt in the last 45 years. Climate change is not a new thing in the southwest, it's been around here for a long time. They've been able to increase their yields on, obviously on trend. And there was a report, I'm not even know if I meant to say this, but I was talking to my husband who works for CSBP, and he was saying there's a farmer in Kalingaree who pulled off 4 tonnes per hectare of wheat, and that is in a decile 1 rainfall, but they had a decile 6 summer. So it's amazing what farmers can do with very little rain. Maybe they just pour the nitrogen, I'm not sure, but it's really when you hear stories about that, it's really encouraging. Okay, so next couple of slides are just a plug for the department. These are the sorts of things that can help growers and consultants in season. Whoops, I'll go back one. Obviously there's lots of different tools out there, but this is just some of the stuff that the department put out. So this is a rainfall to date tool that sort of can map for a location, track how the rainfall was going and compare to what you get historically, and that is a rainfall to date map in terms of amount and in decile. So you can see this is this year, so we've been a pretty dry year. Soil water tool, so this is just a very generic Ritchie model that we use here. So here you've got the original one location compared to a map for the whole Southwest Land Division, and that can give you the break as well. It just gives you an idea of where you are. Potential yields is very, very simple, French and Schultz. I know there's other stuff out there that CSIRO put out and BirdChip as well, but this is just something that we have. And also extreme weather event tool, which is use time data. This is the deep herd weather stations. So they're, minute data, so it can actually tell you how many minutes a location has had a extreme weather event, so it actually does heat as well. So it sort of gives an indication that if you're in Wickerpen North, you might want to go check your crop in 10 days because you've had a frost event, and the corresponding map. And seasonal forecasting, I'm going to get into trouble if I talk about this as well. So Fiona Evans was mastermind behind this, and this just gives a 3-month outlook that corresponds to the blue dot on the map. So basically, these are the challenges that I feel that farmers are facing. They've already been facing because, as I said before, we've had climate change around for 45 years. So obviously, with a later break, you're going to get challenges to your crop and your wheat yield. With an increase in thermal time, crops are now accelerated growth, and so they're going to hit a frost window earlier. Obviously, it's got challenges for livestock. Dam runoff, water scarcity, we're seeing that now down south at Ravensthorpe and at Gardiner. And especially for dairy farmers, there's viability of shade trees. So if the water, with a declining water table, trees are going to die. So they're going to have to find some way of shading their dairy cattle and things like that. And pests and weeds. But on a personal note, I would just say that I think they've been able to adapt to this, and thanks to the farmers for growing some grain for us. And that's it. Thank you.
Thank you, Meredith. We are running a little behind time, so we'll have to move quickly, and I don't want to constract them because we've got the last two speakers are two people who are actively involved in agriculture, and I'd like to welcome now Latham farmer Dylan Hirsch. Dylan manages a cropping enterprise in the low rainfall zone, WA wheat belt, so dealing with the stuff we've been talking about. Dylan and his family have been incorporating novel and best practice technology techniques within their cropping system to improve production and efficiency. Today he will be speaking on risk management, a farmer's perspective. Welcome, Dylan, and he's got off the harvesting operation to actually come down here today, so I really appreciate that. Thanks, Dylan. Sorry.
That's all right. There we go. Thanks, Terry, and thanks to the Institute for having me. Yeah, it is an honour to be here. I think it's about 13 years ago I was not far away from here, studying a module on global weather systems and learning about what that might mean, including increased frost and September heat events and things like that. So, yeah, we've come a bit full circle. Hope we're all going all right, and attention span is a lot better than mine was 13 years ago. My name's Dylan Hirsch. I'm a young naive farmer from the low rainfall zone in northeastern wheat belt. On all the other maps, it's been in the red spot. So just to put it in perspective. We're a typical family business. We don't do anything too special. Despite everything we've talked about, if you have a look at the 10-year return on capital data by Plan Farm, which I've stolen for this image here, it's actually a pretty good place to be. So, why is this? Are we just really good farmers, or, what's causing this? And, we can pat ourselves on the back, but, there's a bit going on there to explain, we've got farmers producing some really good return on capital in the north, but a lot of them still dream on farming a bit further down in the red zone. So, the drought is a severe risk to our cropping operations, and so whilst the return on capital average is quite high, this can range from -25 to +35 year on year, and the land prices are heavily discounted to reflect the risk of seasonal volatility. So a lot of farmers will talk about average yields, and I reckon they're actually pretty meaningless when we talk about averages these days. We farm a range. We try and produce somewhere between 1 and 3 tonnes per hectare, and I think that's a bit more meaningful metric, unfortunately. So while our yields may not appear to be increasing, our water use efficiency is slowly improving as we're adopting better practices and technology into the business. And just for a bit of perspective, I think we're a couple of weeks into harvest, and we've had a very similar year rainfall-wise to 2007 on our place. See if I can see on that. Anyway, and I think we're going to end up with a yield pretty similar to our 10-year average. So I think that's really really gives us a lot of confidence about where we're going. So the new practices we're adopting have been driven by a changing climate. And we didn't really know that at the time. It's all been about increasing efficiency and productivity. But when we look back at them, we can see that the changes we're implementing are really to try and mitigate some of the negatives, which has been a drying in our April and May and June, and making more of the opportunities, which has been a slight increase in our summer rainfall. How have we got there? Well, probably the biggest one we've happened in the last 2 decades has been getting the crop in early. So we haven't sown into mud for over 4 years now. Getting the crop in early and dry and in a timely manner is probably been, whilst not the most exciting, it's been the key driver to getting a good economic return. So we can't no longer afford to wait for the opening rain. If the break is late, we get it in dry. And the late sown crops are often hammered by September heat stress and are rarely profitable. Retaining the moisture and sowing into it has given us a few opportunities. This area is something which I'm pretty excited about in the next decade, because I think there's a few breeding traits and technologies coming in that will increase these opportunities. Increasing the rooting depth of our soil, a bigger bucket, as Yvette spoke about before, that's been really successful for increasing the profitability of our operation. We're improving the pH of the subsoil and investing in hybrid seeds, which can do more with less, but it's a very costly exercise. Fence lines are being removed, and we're doing more with less labour, less machinery and less people. So while we've been able to respond to some of the challenges the climate has thrown at us, our answer to... Sorry, I'll leave. I'm glad the volume works. So I think we've done pretty well to respond to some of the challenges, but the last one is the more erratic seasons and the more extreme is something that is still difficult. And our current system of managing this is to maintain a high business equity and be frugal with their expenditure. And that's the same thing we've been doing for decades and hasn't really changed. But if we're going to compete globally with markets and capital, I don't know whether this status quo is going to carry us into the future. So land prices and profitability are increasing despite the changing climate. Will this continue? Probably. Increasing costs of production and high frequency of crop failure will continue and makes it harder to invest and allocate the capital into the cropping enterprises. Corporate farmers are getting a better geographical spread and have deeper pockets, therefore perhaps better equipped to manage the risk. So how do family farmers compete for that capital? How do we retain the skilled farmers on the land and convince others into the industry? And with these challenges in mind, I actually went on a Nuffield scholarship in 2018 and tried to have a look at how are we as farmers going to address this in the future. So I just want to look at one example, and I went around the world and tried to find similar areas or similar that have the same sort of production risks that we do in WA, and the reality is it doesn't really exist. We're really on our own. Probably the closest I got to was northwest Montana in the USA. So I came across Chester. It was a small town, had a few hundred people. The businesses rely solely on agriculture. So droughts are their major production risk, 1 to 3 tonnes per hectare of wheat, and they're improving. The farm costs and their profit margins are pretty similar too, but there's a couple of key differences that I think affect the farmers and also the communities around them. And it's probably underpinned by that subsidised US crop insurance program. So because of the US Farm Safety Net program, farmers could go out of business a little bit slower. So with performance numbers that gave them and their financiers an early warning. Land was more sought after because it was low risk and capital could be accessed pretty readily by a diverse range of people. So for farm lending, it was actually very similar to what we might see in our residential market. So meanwhile, back home, our profitability is much better, but our economic development is still much further behind. So what are we doing? What have we done since then? And I guess, what did I take home from that and how have we applied it in our own business? So, I mean, there's a lot I'd like to apply, but baby steps. The last 3 years, our business, we've purchased weather derivatives or index insurance, and that's to hedge our risk of drought. So compared to multi-peril crop insurance, which many of us have heard of, it insures our predicted water sufficiency rather than our historical one. There's no risk of moral hazard, and it's available immediately on every Bureau of Meteorology station around the country. And we're pretty lucky because we've got one right next to our farm, and our farm, thankfully, we farm in an area where we have pretty much one variable, which is the rainfall. So we've received our first payout last year, and we'll probably get a small one this year as well to cover the cost of taking it out. So we use the product because it gives us greater certainty in our financial position at the end of the year, and it gives us greater confidence to leverage our business and ourselves. I'm confident that we can be more assertive with our grain marketing and leverage more than perhaps we would otherwise. And if we can pay for the cost of those products, which are significant, then I feel like we'll be ahead in the long term. But I think there's still plenty of improvement and potential for these products to come. So, is weather insurance the solution? Well, maybe it's part of it, but there's quite a few barriers we need to overcome. You know, the weather cover we use has an upfront cost of about $200,000. So that's at the start of our growing season, and that means an extra $200,000 of peak debt when we're already perhaps trying to leverage to trying to put a crop in. So that puts off growers, even growers who can see the benefits. It's pretty off-putting. There are ways around this, but it requires the cooperation with our financiers and local insurers. The other one is many Australian farms haven't really had to understand financial products like futures and options because we've always had RWB and pools to rely on to market our grain. So I think this is changing, and as we become more educated around how to use these, I think we'll see that barrier become a bit easier to get over. And the other one is there's a few regulatory hurdles as well. You know, in WA, we can't actually purchase as an insurance. We have to purchase as a financial tool, which is not actually accessible for a lot of farmers because you have to prove that you have the financial know-how and nuance to use those facilities. And the other one is we've got data. So compared to other countries in the world, which I think we're catching up, we're doing a good job, but there's potential there. We're just having that background in data and closing those gaps to be able to use some of these instruments in the future requires data. So yeah, I think I'm happy to answer. There's a few questions I think will stick around later on the panel and afterwards. So yeah, sort of leave you with a few maybe things to think about, and yeah, I'll leave you on to Simon. Thank you.
Thanks very much, John.
No worries.
Thanks very much, Darren, for that insight into your business and how you conduct it. Now, we'll now move to our final speaker this afternoon, Mr. Corrigin farmer Simon Wallwork. Simon and his farming manage a broadacre crop and livestock operation over 3,700 hectares. Simon was involved in the National Climate Champion program in 2014 and last year teamed up with his fellow farmers and industry participants to form Ag Zero 2030. Today we'll be speaking on Ag Zero 2030, a farmer's motivations. So welcome, Simon. Thank you.
Thank you very much, Des.
And thanks for having us here today. So I'm a graduate of the Ag Science faculty, as is my wife Cindy, when the tavern was headquarters. I don't know if it still is. Chemistry in Friday afternoons was never a good idea. Anyway, that photo was taken a while ago. I've got 3 kids. The 2 middle ones are at boarding school in Perth now. I had a mullet in those days. And the little one is hassling his parents out about climate change at home still. So I'll get back to that later. So I'm from the city originally, and my wife is one of 3 daughters, the oldest, and the other 2 daughters married farmers. So I was given the opportunity to go farming in 2003. I was working as an agronomist prior to that. 2003 was a really good season. I knew nothing about farming other than the technical side, I suppose, of agronomy. Put the crop in dry very early. It rained quite nicely, there was no frost, and we killed the pig pretty much. And I was wondering what all the farmers were complaining about. Farming wasn't that hard. Then came along 2004. I did the same. I dry sowed the whole program with a DBS machine we just bought with the proceeds from the year before, because I knew all about dry seeding early crops, the benefits of that. And I dry seeded half the program to wheat, and when it got cold in September, the whole lot got frosted and it yielded 300 kilos. And there were some heat stress events as well. So I'm beginning to understand climate variability. And also began to understand that my 2 key profit drivers were probably frost and dry. So the name of our business is Hacienda de Trigo. We don't grow much wheat anymore. Trigo is Spanish for wheat. We grow a lot of barley. And the reason is in 2005, so early again, side by side, barley versus wheat. We got frosted again, but the barley yielded 1.4 and the wheat 0.36 through its slightly better frost tolerance. But to the bottom line, that's a big difference, obviously. So that was our first fundamental shift in our business. We started increasing our barley area and we got up to about 90% at one stage. We've dropped that back a bit now. Coupled with that is improved varieties as well, high yielding, longer season varieties, which allowed us to sow early, of course. Okay, so we skip forward to 2010, the driest season on record for the South West Land Division by a country mile, 30% drier than 1914. That was a bit of a wake-up call for me. We were leasing a farm east of Corrigan as well, heavy country, and that only had 73 mils of growing season rainfall. So the barley out there yielded 100 kilos. Interestingly, at home, on the lighter soils, we still got 1 tonne per hectare in this paddock by sowing early into summer moisture. So it is amazing what you can do. However, that year had a real fundamental effect on me, and I really wanted to understand a bit more about climate variability. And so I got involved in the Climate Champion program, which was funded by MLA and GRDC. And this was essentially about farmers around Australia getting together, sharing ideas, telling our stories, interacting with scientists from CSIRO, Bureau Met, etc., talking about climate variability. And that was the language used at the time. But as we sort of got beneath the surface, what we're really talking about was climate change and the shocks that we were experiencing like 2010 as farmers all around Australia. It didn't matter whether you're a cropper in WA, an olive grower, a grape grower in Victoria, a cane grower in Queensland. We all had similar stories. I was a first-generation farmer. Some of these guys have been, their families have been in farming for multiple generations and were seeing things that they hadn't seen before. And it also got that process. We were guinea pigs for the Climate app. We provided feedback on that, which has been quite a high adoption in the farming community, a little app you can have on your phone to look at trends, etc. It also got me looking into my local trends as well, and I think we've been through enough of this today to see what's happening with growing season rainfall. 2020 has been a dry year, and it fits into the top 5 or bottom 5, which depending which way you look at it. Interestingly, 3 of those years have occurred in the last 10. And like Dylan, I've broken it up a bit more and beginning to understand that it's really that sort of autumn, early winter period where we're seeing our biggest decline, up to 34% decline
in the 2020 average compared to the 1910 to 79 average. And we're really seeing that in livestock systems. To get a well-established clover, grass, pasture is almost impossible with this decline nowadays. Interestingly, we are seeing a slight increase in the summer rainfall trend in our area. We also talked about frost and the incidence, increasing incidence in our area. So the barley strategy did work and continues to work, particularly when I have the frosty years. This is a gross margin chart. It tends to win, but 2009, 2010, 2009 was on the back of the financial crisis where we had very low grain prices and high costs at the beginning of the year, coming out of the boom period. And then 2010 was obviously the climatic conditions. When your gross margin's near zero, you lose lots of money because you don't have your fixed costs there. So just adopting barley wasn't going to fix my problems. We have to continue to adapt. And I've been involved in the Courage and Farm Improvement Group for a long time. We've done a lot of on-farm trial work, testing soil cover, wide rows versus narrow. We spent plenty of hours on that auger there with a volumetric soil moisture probe. So always testing new ideas, trialling things to see where we can make the next improvement. Comparing different seeding equipment, chemical fallow. This one with the cattle is using grazing crops as a strategy, perhaps to manage the frost risk. I still want to sow early, but can I defer that flowering by grazing with cattle? Interestingly, when I was looking at this sown early, April, I can see the amount of feed I was sowing a crop, yet we get no feed with a regenerative pasture situation due to that dry autumn. So we started sowing barley as a fodder in early April, now early March. We sow the whole farm. We've got sheep and cattle, but we sow the whole farm, and we no longer rely on regenerative pastures. And that's been a bit of a game changer for us. We're now increasing our livestock proportion of our business with good livestock prices and the ability to run a higher stocking rate in our area. The last 3 years, sheep and cattle have produced higher gross margins than crop for us. The bottom one is we've done EM38 surveys across our properties, and we run trials through them and so we can analyse and compare on like soils, because soil type has a huge influence on the end result, as I've seen from leasing a heavy farm compared to the light farm, and perhaps some of the efficiency in WA comes from our soil types. More recently, the next big step for us has been soil amelioration, which we covered. It's quite unusual to see massive responses like this. On the right-hand side, that was moldboard ploughed on very non-wetting soils compared to untreated on the left. So that's been a game changer. We've been ploughing since 2014. And this is the sort of thing we see at the end of a year in a dry year after we've ameliorated. We've increased that bucket of moisture, the crops finish softer. Typically in the first year we get 900 kilo yield response. And I've got plots this year that will produce, I estimate, 500 kilos 6 years after ploughing. So it's a sustainable improvement. We've also, mobile ploughing is a slow process. We do a bit of chem fallowing. You need nice moist soil to do moldboard ploughing so you can get a nice flip. So we experimented a few years ago about ploughing in September and sowing fodders as a cover and then grazing it with our cattle. And we're seeing some yield benefits now following crop despite using the moisture up over summer. So there's some interesting stuff happening there. So I guess I've talked a bit about adaptation, but is that the full story when it comes to climate solutions? We've obviously got an issue that's directly affecting our industry, and so there's some questions that this raises, and it's not only me but other people in our industry are sort of trying to work through these questions, and these are the sorts of things. Are we part of the problem, like we've been told we are, or are we part of the solution, or are we both? what will consumers and markets want? What are the risks, market access, liabilities, etc.? What are the opportunities? Can we have open and respectful conversations, and can we put the trust back in the science? So on the back of that, our family has been working through this stuff, and we know the trends, we accept the science, and we want to do our bit, and that's where our son comes in. He wants to know what we're going to be doing for his future. We can see a steam train coming our way. We don't want another live export situation where we're unprepared for it. We grow a lot of barley in our business, and just doing a simple Google search, I can see that most of the large brewers in the world are either carbon neutral or heading to carbon neutrality. I think they're going to want carbon neutral barley from us, and I'm already receiving those signals. Personally, as a farming business, can I supply that? Of course, we need to understand how much carbon we're emitting, which we need carbon calculators as accurate as they can be. And a lot of that work's sitting within organisations, but unfortunately we haven't been able to open the conversation. So our farm emits 1,200 tonnes carbon equivalent per year based on our calculations. They may be a little inaccurate at this point. And we think that's achievable to become carbon neutral with, say, on a purely offset basis, 120 hectares of trees planting, but also if we combine that with emissions reduction, we think that's achievable. So that's our situation. Through the power of social media, I posed a question about a year ago whether other people were concerned about this issue, not just adapting, but mitigation for our industry and being part of the solution. And it was quite amazing, the response. A few of us got together, and also some industry organisations got together with us, and we put together a forum. The Minister opened the day for us, and we had some guest speakers like we do today to provide some information that me as a farmer hadn't really come across before. Some of this risk and mitigation stuff, some of the stuff Dylan's doing, some of the carbon market stuff, which is starting to move now with interest from mining companies. So out of that day, we formed this organisation or movement called Ag Zero 2030. And essentially the main goal, to put it simply, is to help promote a positive response of our industry to climate change, to be involved in the solution. And we developed 3 goals on that day, and these are the goals. We've got an aspirational target of moving our industry to carbon neutrality by 2030. Whether that's achievable or not, I'm not sure. But unless we adopt carbon calculators, we don't know. We want to share the positive stories, not for our own sake, or for our own sake, but also for the consumer's sake, so they understand that we are part of the solution. And that's getting back to that live export situation. We're trying to prevent that sort of situation again, where change is forced upon us. And also we want to contribute to positive climate change policy. And these are some of the organisations that are supporting us with this. And there's some things we've already achieved in the first year. We have opened the conversation. We are coming across farming organisations that are either carbon neutral or aiming towards it, which is interesting in terms of shared learnings, but also positive stories for our industry. There's a lot of work to be done in climate literacy. The average farmer doesn't understand the jargon. We need to simplify that language and bring the farmers along with this information. We speak at industry events like this to share these messages. I'll let you read the rest. And this is just some of the other things that have popped up. We organised a day with the West Australian Farmers Federation. We had a speaker from NAB. We had Trevor Lucas from CBH. CBH doing some really important work on sustainability markets, including emissions. We had a farm consultant who's adopted carbon calculations to provide to his clients, and some other speakers. And that information really got the conversation going. And now West Australian Farmers Federation, as agro-political group, are now working towards a more progressive climate change policy, which is really needed by our industry. We had a thing going called 2030 Moves, where it's really just trying to get this story through. Is about doing exercise stuff like riding your bike or push-ups or whatever, do 20, 30 of them, post on social media and sort of relate it back to this movement. So it's things like that. So that's pretty much it. So thanks a lot.
Thank you, Simon, for sharing those thoughts and the work you've been doing in that space. So really appreciate you being here and presenting that this afternoon. Can I now ask Richard Hudson to come forward, who's going to oversee the panel discussion. Richard will be well known to many of you. Richard is a graduate of this university, and he spent more than 2 decades reporting on rural matters around the industry. He was appointed the ABC's executive producer of Rural WA and WA Country Hour in 2007. Face well known to us. Welcome, Richard. And can I ask the presenters please to come forward up here, and we'll conduct this next short time. We are a little over time, but I think we've got time for some questions and a wrap-up, Richard, so over to you to keep it rolling.
Just thought I'd mention very quickly, it was fortuitous last night that I've got 3 daughters, and my eldest daughter came home and we had the normal question of how was your day? And she said, oh, it was great. We had a little documentary today that our teacher showed us. And I said, oh, you know, what was it about? And they showed them a snippet of this particular documentary, and it was called 2040, and it was all about creating a sustainable future. And she went into a bit of detail, partly to do with making things a little bit more efficient and using all sorts of data analysis and things like that. And then I got asked to contribute to some of her homework. It was a maths homework, an investigative bit of homework. And it was to do with, the first question was, what is the Internet of Things, IoT devices? And I said, what a stupid bloody expression that is, because I had to look it up. I had no idea what it was. And then I went through the definition of this thing with her, and we zeroed in on what it actually meant. And by the time I'd actually figured out what it meant, I then am a big fan of giving examples so that you can explain it to people. And the example that I ended up giving was to do with farming, of course, and it was basically the Internet of Things, if you're not aware, is the use of electronic devices without human intervention. So from one electronic device going to the internet, bouncing back and having that feedback, taking out the idiots like myself who can stuff things up and cause delays. And so the example I gave was having soil monitors sending details off to the internet, coming back and maybe triggering drip feed irrigation like at David Stote's place, just south of Broome, and taking out the need to have someone in the middle. Just thought I'd mention it because it was fortuitous, because those sorts of things have come up this afternoon time and time again, particularly when we were starting to talk about the water side of things. I thought, Dr. Oliver, you might have been particularly impressed with that little example I gave anyway. So firstly, I wouldn't mind just starting with the 2 farmers. I like to keep things down at the ground level. To the 2 farmers, when you first heard the opening address from Dr. Stephen Crimp, can you be honest? Did it send a bit of a shiver down your spine?
Probably not for me personally, because I've had access to, through the Climate Champion program and my own sort of research, about some of the projections, but it's also a challenge, so that's exciting.
How about for you, Dylan?
Yeah, I think it's because we hear a lot. So I guess coming from the background, especially coming through university, I think it's not a shock to hear that, but it is concerning. So it's something I'm mindful with the decision making and long term to make sure it gives extra drive to improve our productivity, because we've got to be ahead of these changes. But then I think when you get those messages directly, if you're not prepared, it can become quite a shock, and I think that's where we see there's still, perhaps in our industry, I think there's a bit of maybe resistance because it's such a shock when you hear some of those things.
When you say resistance, do you mean from farmers who would argue that it's not climate change, it's just climate variability?
Yeah, absolutely. I think you're spot on. So, yeah, I think it's we've got to look at it pragmatically, and certainly I see a lot more. It's easier to see the challenges ahead of us than it is in maybe those few opportunities as well. But I think the more educated our farmers are becoming, I think the more we're going to be easy to be able to see them as not being pure threats to our industry, but just challenges that we might be able to overcome.
I don't know about you, but I was looking at the sort of things that Dylan is up to and the sort of decisions he's making to make sure that they're more profitable and to make sure that they are in that top bracket when the planned farm benchmarking figures are coming out each year. And I find it staggering because you now end up having to be a farming expert, a climate expert, a business expert, a market expert. It's okay for people who are fairly bright and up to things like yourself. What worries me about is for the farmers who are maybe not so skilled across the board. They might be wanting to get there, but it's just too hard. Do you think there are a lot of farmers fall into that category?
Absolutely. Yeah, I think there's a lot of farmers who see that and think that they have to be an expert on all those things. But I think the best farmers that I know, that I look up to, it's about who you do trust and getting advice from experts, not necessarily having to, be full bottle on everything. But, I think farming is actually a lot easier in that respect than what it was because a lot of farmers have, several consultants that they can call on to for those sort of things. So as long as we have, that third-party advisors and researchers and experts in our industry, I think we're going to need those more. We can continue to need those people and more so in the future.
So
I think there's probably plenty of people in this room that are part of the solution there, and we really need to focus our thinking on this climate change, and really a lot of work's already been done, but it's in like that bank account of information. Unfortunately, due to the politicised nature of this topic, it hasn't been allowed to flow like other agriculture issues have. So we need to get that trust back and get that information flow, and farmers will then move forward with the assistance of people like these guys.
One thing you said, Simon, though, you said we can see a steam train coming our way. Do you think there are a lot of farmers haven't actually noticed that the steam train is sitting on the tracks?
When I say steam train, it's not just drought and frost. It's carbon neutrality, consumer expectations, a whole range of issues. But once again, the average farmer hasn't even had access to that message through just the debate, pretty much. Yeah.
Have we managed to get?
I think we will continue. We will ask questions from the audience.
Yeah. Does anyone have a question just to off the back? I've got 1 million, by the way. I'm just being polite. Just in the middle in the black. If Kadambot Siddique is too slow, I'll just keep asking questions as well.
No.
Fire away.
Okay, now I've got it. So Fiona Evans here from Murdoch Uni. I work in big data and agriculture. Dylan, you talked about needing more data for financial tools, for developing financial tools, and Simon, you talked about carbon calculators. I'm just wondering, what other sorts of data needs do you think you guys need to be able to help manage climate change, climate variability, and how you might adapt to that and even think about mitigation?
Thanks, Fiona. So I guess from my perspective, on farm, there's things like things like to make better decisions, like knowing how much moisture I've got in the soil to be able to optimise the crop growth and things like that. But in my slide, I was probably alluding to the overall industry. So our banks are part of our industry. And so for them to, and the other alternative capital providers as well, for them to allocate capital the most efficiently to profitable producers, they need to understand where to put it. At the moment in Australia, apart from private and volunteer benchmarking data, it hasn't really been done that very well to be able to compare and assess businesses. Whereas if you look in other developed countries like Canada and US, which have had government schemes that require that data, they've got really, really great, very high resolution business performance and farm production performance data through the network. So for insurance or finance purposes, it's very easy and very low cost administrative work to be able to conduct assessments and to allocate that sort of capital. So that's where I think we can develop, and that's the sort of problems I think we can get better at. And I think that will certainly be part of the solution going forward, maybe not a direct one.
From my perspective, I think there's a positive story around efficiency in terms of, for example, what Phil was talking about with methane and productivity of animals and stuff like that. Emissions and productivity don't need to be mutually exclusive, so it would be good to have more research, more data on some of that stuff. Yeah.
If I can just bring in some of the other panellists here. One thing that Stephen Crimp mentioned, and also Meredith Guthrie mentioned as well, you talked about the flowering window shortening because of climate change. Do you think there's enough breeding work going into that factor? Because breeding takes so long, and I just wonder if we're constantly behind the game.
Yvette, you got any? I haven't got any comment on that.
I guess, because again, I'm not a breeder, but they have been using the tools like AppSim with the climate models to look at this window, to look at what kind of genetics and breeding is required to try and meet these new climates. So they have done a lot of modelling and work to try and figure out what it is you actually want in the genetics to meet our environment. So.
Professor Kingwell, what are your thoughts on that? You're an expert right across the field. I know you didn't touch on that today, but I know you'd be champing at the bit to have a say.
So I have been in discussion with various breeding companies across Australia, and like many people here, they're very well aware of the climate future, and they are already hard at work and have been hard at work for many years developing cultivars that have heat tolerance, particularly under our spring conditions, that have different lengths of growing season. So, and the other thing is that people talk about breeding taking a long time. That was true. It's less true now, because just as in many other aspects of science, there's a lot of technology that now underpins plant breeding, so they can much more rapidly develop a variety than was the case 10, 20 years ago.
General question about pastures. The sort of impending failure of annual pasture systems within our mixed cropping areas. How likely do you think we are going to be able to design and have a plug-and-play option for a new pasture system that not only adapts to changing climate, but does a good job when it comes to carbon?
Who'd like to volunteer to take that one?
I could probably start, if you like. I think farmers are already starting to do that through necessity, such as sowing either barley or mixes, like vetch is becoming quite a common mixed partner. We can grow pretty much anything in spring. It's really that autumn period that we're trying to really fill the feed gap. But I don't think it's going to be any one solution. I think that's part of it, and then you may leave some of your traditional subclover pastures for that spring grazing. And then I'll hand over to you, Phil, for the other part.
Yeah, no, well, I think you've hit the nail on the head. I think we've got to be innovative about what we're choosing to grow. And I guess at a really high level, something that I try and bring myself back to is this idea of G by E by M, which is the right plants and animals in the right place managed in the right place, managed in the right way. And it's that G bit. What is it that we're growing, and what are we considering diversity? How much diversity are we considering? Are we willing to take that diversity on? Because I think at the end of the day, that's where we'll get our versatility, our flexibility, and just, I guess, coming back to the breeding perspective, one of the biggest challenges, I think, in that sort of situation, so we've got various options, I suppose, available to us to be innovative in how we use them, but the key to any good breeding program is what you're breeding for. So what are the breeding objectives, and do we need to shape our minds a little bit? The obvious ones, heat stress and those sorts of things, but then if we're talking about pasture systems and where we're going to fail or where they might fail, maybe we need to be a bit creative about what we're targeting for our breeding programs to make sure that that's what we're building, a database, if you like, of potential species that can be part of our grazing systems. And with that diversity comes challenges with the grazing of that diversity. How do we best manage that? And you know, that's, thankfully, animals aren't as stupid as some people think they are. But so there's an element of that, but there's an element of data that you're talking about as well to help better manage and better make decisions. And it's that feedback. How do we get it? Technology. So there's the whole stack of things that will have to be implemented, I think, to try and meet the challenge that you're talking about.
Phil, in your talk you mentioned the sort of research that's going into looking at which native shrubs can decrease the methane production. What I'm wondering is what percentage of farmers might be dying to get their hands on those research findings, because the question I often ask our rural reporters is make sure you cut to the chase when it comes to the dollar, the hip pocket questions. They're much more interested in, is this research going to either save me money or is it going to make me extra money? Does that worry you, that a lot of the research is being done and it's getting these findings, but the farmer, it might not be the main thing farmers are after right now? So,
in answer to your first question, what percentage? I think 100% of the farmers would. No, I'm only kidding. Not that I'd be biased or anything. No, I think that's a logical question, is that they have to be considering the cost of those things. But I think the way in which they're costed is changing as well, in terms of the relation of what Simon was talking about, in terms of changing consumer expectations about what it is that's going to set a dollar value on the product that you're producing. And so as we see changes in that, we'll see changes in the attitudes towards what they're willing to pay to change the system to get the product that can be sold. Yeah. So I think that's always going to be a moving target. Oh, got a hand up over there.
Richard, Steve Pels. Anyone, I think, listening this afternoon has got to be profoundly depressed about the realities of what's happening to our climate, and there are no simple solutions, but disruptive technologies do come along. I'm not suggesting any of the panellists there can identify them, but it doesn't mean that there may not be some. For example, ways of removing greenhouse gases from the atmosphere exist. They're just energy expensive, Ross, and yet we don't use the 3 months of solar radiation that we have highest in the world during summer. So either our opening speaker or Ross or someone else, do you see within the realms of possibility that there are disruptive technologies that might reverse some of the greenhouse gas and particularly CO2 levels, which have gone from 280 to 420? Is there any possibility of that occurring over the next 20 years?
So my quick answer to that is, obviously there might be, but there's nothing that I'm aware of, and you could imagine there are lots of venture capitalists who would be throwing bucket loads of money if there was even the sniff of an idea that, because this is a global phenomenon with global returns to any breakthrough technology. So I don't see that happening. I think the biggest breakthroughs are likely to be where the emissions are greatest. So in agriculture's case, if you could have a means of reducing methane emissions, as Phil was saying, that's 70% of agricultural emissions are coming from the methane produced by farm animals. So I would start there. Obviously, using solar energy for electrification, using solar energy and subterranean sources of water for as water sources rather than surface water. So there's a lot of things I think that could occur, but I think most of the emphasis unfortunately has to be on adaptation. So for example, I think one of the issues facing WA farmers is the big question, is it in my strategic interest to buy out my neighbour? And I think increasingly the answer is no. That I think rather the future of farming will be a diversified portfolio of farms that expose yourself to different spatial risks across the sub-regions and exposing you to different agricultural markets and therefore exposing you to different price risks. So I think the future of farming is more about risk management, frankly.
Before we move on to the next question, if you think you've had a long day as well, Stephen Powell started his day at 2:30 this morning with a Zoom hookup to the United States. So, just at the back there.
Thank you. Alex Gardner. I'm a professor of law specialising in natural resources and environmental law. The question I want to pose is why today, and more generally, I don't hear a strong call from the agricultural industry for a reduction in greenhouse gas emissions. Now let me give you the context for that question. And I'd like to start by just acknowledging the outstanding quality of the young farmers who are here today, Dylan and Simon. You guys are clearly at the top of your game. But Ross has just indicated that the expansion of the successful farmers is maybe not the best for the future. So Dylan, it was interesting to see your data on productivity and commercial return. But I understand that the northern wheat belt lost a third of its population in a decade in the 1990s. And those things to me, the top of that chart with Stephen Crimp is social sustainability. And I just wonder whether we're going to reach a tipping point where the fantastic improvements in productivity are not sustainable because you just can't grow stuff without rainfall in Western Australia. And so I'm puzzled why the agricultural industry doesn't actually voice stronger concern about Western Australia's sustained increase in greenhouse gas emissions. I'd be interested to hear your opinions on that. Thanks.
Do you want to kick it off, Simon? It's probably one of your pet subjects.
Yeah, it's a good question, and I think it's in the context that we might be 10 to 14% of the emissions, ag sector, but obviously the elephant in the room is up north, oil and gas, etc. And my sort of answer to that is that we can't ask someone to tidy their room up if we're not doing it ourselves. So I think that's part of the reason why it's important that we are attempting to change, to aim to carbon neutrality in our own industry as well.
Would you like a louder voice from the representative bodies on behalf of farmers, though?
I think hopefully that's starting to change. It's been a slow process and we're probably 10 years behind where we need to be, but hopefully that's starting to change now. And certainly industry organisations that are represented here today are certainly doing some really good work. So,
when you're 10 years behind, I keep going back to that slide Dr. Crimp had where he said, I'll start it at about, and you just watched it tick over from 1880, and the colour changing was pretty amazing. Just at the front there.
Philip Gardner, no relation to Alex, but nice to be a friend.
Still different.
The question I have is about the contrasting difficulties we have in our enterprise development in agriculture. For example, if we go more and more continuous grain, the organic carbon begins to collapse. And yet if we're going to have less and less growing season rainfall, we need to have a high level of organic carbon because it will hold more moisture in the soil for our crops to take out. So the only thing which keeps us, in a sense, going, according to from what Ross Kingswell said, is that the high prices in our grains will be a key factor to sustain our grain industry. But if that rainfall keeps on falling, we've got to get the organic carbon in there. And the other thing about organic carbon is I don't think it was mentioned at all, maybe one alluded to in the discussion. And I think that my view is that's a very important thing, not just for the sequestration, if we're serious about climate change and global warming, but also about productivity. Is there any comment that you might have on that?
I'll probably start so from a young farmer who's pretty involved in local research and development groups, the focus on soil carbon is there. The problem is we've got, in a cropping perspective, is like you alluded to before, is that we haven't seen very many practical examples of being able to actually increase our soil carbon sustainably over time. We're pretty comfortable that sound practice, we can keep it plateaued and prevent it from dropping further, but to actually be able to build up the soil carbon, I think is a goal. But I think without actually acknowledging that, we want to be closer to carbon neutral or have a secondary measure in mind, it hasn't been a particularly focus for much research to be able to actually prove how we can increase that soil carbon for either for carbon market or productivity wise. I think I've seen it in the pasture, long-term pasture, but for cropping, I'd like it to be more research done in it because I think we can figure it out. But it's as I know there's a lot of farmers like myself looking for that, and hoping that in the next few years that'll happen.
There's actually a paper that's just come out today from the Australian Farm Institute, and there's a whole heap of authors have contributed to it. But if I can just read out one small thing I just found very interesting. Richard Dickman is the head of public and government affairs at Bayer Australia. And he outlines evidently in his paper that the plant science industry's involvement in the development of conservation agriculture practices, and he's forecasting how such companies like his are likely to be involved. What he's saying is he thinks they're going to be focusing more on integrated biological and regenerative systems than it has been in the past. And learnings from practices that led to weed resistance development are incorporated into new strategies. Ross, does that surprise you?
Not really, no. I think globally, eventually, there will be parts of some markets that require sustainability monitoring, and having access to that market will be underpinned by you having an auditable process by which you can prove that the way in which you are producing your agricultural commodity delivers sustainability in an environmental sense. And I think increasingly that will be the norm, and so it'll be visible either by price premium or access. So you can only have access to a market if you have an auditable way of verifying the legitimacy of your agricultural practices, or the products that are produced are given a premium. So I think that will increasingly be the norm, and I think that's an opportunity for Australian farmers because we are not low-cost producers, and therefore we need to find either markets or price premia that pay for our higher cost of production. And I think increasingly, in a global sense, we will stay as small to niche players in global markets of agricultural commodities. And because of the sophistication and professionalism of our agricultural industry, I think we can achieve that. That is, we actually can monitor and prove that what we do is environmentally sound.
Just in the red shirt.
My name's John Hamblin. It seems to me that the point that's sort of sitting in there over the top of us, but we're not taking into account, is that the world likes stuff, okay? And what that means is, to get more stuff, you need the price of things to come down. And the price of food as a percentage of our GDP spent is always falling. And when we start then saying, well, how do we move this out into a world scale, what we find is that the population's going in the other direction. And so to go back to the last question, what we have to do is improve production without taking more land. And if we go to regenerative agriculture, we know that so far the yields go down. And so the only solution in that model is to take more land. And that means that biodiversity, water supplies, etc., are going to get hammered. And my own view is that what we're going to have to do with cropping is say, I'm very sorry, but in the short term, and I'm talking now 70 years, okay, in the short term, we have to go for more intensive agriculture, production of the key major crops. And wheat is a classic example. Now, how we're going to do that with falling rainfall is a very interesting question. I don't have any answers, but I was very pleased to see that Corrigan's rainfall is falling roughly a millimetre a year. And interestingly, that's the same as the Chapman Valley. I don't know whether that's a question.
I was just going to say we'll take it as a statement, but it's a good statement to end on. Thank you. Just one final bit to wrap up from Corrigan. I actually reckon Lex Stone would have thoroughly enjoyed being here, don't you think? I went out to Lex Stone's place at Corrigan a number of years ago, and he's very, very proud of his salt bushes and his experimental work, and a lot of what was touched on today, he would have just been dancing around at the back with his beard, just getting very, very excited to hear this sort of a talk. Ladies and gentlemen, would you please put your hands together for the panel?
So would you like, please join me once again thanking all of our speakers for sharing their expertise, invaluable insight, and to Richard Hudson for facilitating that discussion and summing up the ideas. Thank you also to Terry for leading us throughout the day. So just, would you just hand over some presents? I thought Phil doesn't get that. Yeah, no, it's okay. Yeah. And while that is going on, those who want to watch today's presentation again or share your experience with friends or colleagues, I'm pleased to share that today's event has been recorded in full. The video will be published online tomorrow. We will also be sending out a short post-event survey to all audience, which I encourage you to participate. The survey is your opportunity to suggest topics for 2021. Hopefully, we can do that in July, which is expected to be held in July next year. Then I just wanted to show our new website. Rosanna has been working hard on that, previously Laura Skates. So please do visit our website, and if you have any suggestions, send it to Rosanna. Now, finally, the Institute will be holding its 27th Hector and Andrew Stewart Memorial Lecture on 17th November. Again, this has been postponed because of the COVID. The lecture will be featured by Dr. Graham Robertson. All of you know him. and he's going to give a talk on food security, but more focus on agriculture in Western Australia. We heard from Ross Kingwell, we will be supplying wheat to other parts of Australia if we don't get the drought here. Although the event is quickly sold out, we will be live streaming the lecture and sharing a recording on our website and social media. But if someone is dropping out from now till the event, we'll include people on the waiting list. The formal program is now drawn to a close, but the next part is equally important. I think you have a lot of questions, so the panel members are going to stay around. I invite you all to join me for some refreshments outside the terrace. So we'll lead that through. And of course, you can enjoy. And thank you again. But before I close, I would like to thank Rosanna, then Cora. Cora is working somewhere now. And also Diana, then my two colleagues, Professor Phil Verko and Professor Wallace Cowling. Thank you again.